Well, good evening, everyone. This is Carl here, President of Dallas Personal Robotics Group. I'd like to welcome everybody to the 1st of September edition of Robot Builders Night Virtual, still stuck at home, but it lets people join from all around the world. And tonight we'll follow the usual format of just going around the table, around the meeting hall here, and to see what people have to say about their different projects during the week. After we do that, then we'll jump in and talk about our regular September meeting and some discussions follow up from last week on the contest. But first, welcome, Donna. First, what we'll do is we'll go around the room and just talk about personal projects this week. And Doug D., I think you offered to jump in there, so please take the floor.
Okay, so as you may recall from earlier meetings, I've been champing at the bit trying to get around this racetrack business, following the line, and I think they're behind me as part of my track. And you know, I'm just having a lot of trouble with that. My sensors just keep falling off the line. They're not coming together. So I'm going to be reconfiguring my robot to really just cram those things together. But while I'm taking a break from that, I decided to get on to my OpenCV stuff, because it's really something I wanted to do for my main robot. It needed to be able to see. And I signed up for some courses with a place called Pi Image Search, and I'll put it in the chat, the link to that. And they have some interesting ways to use the OpenCV with Raspberry Pi. And I have my Pi here. I hope it's kind of on the camera now. I got my little Pi camera on it, and I've got a web camera on it. I've got another webcam that I'm going to play with that's actually better than that web camera. And somewhere I've got my RealSense camera, but I can't find it right now. It's in that pile of junk back there. It'll come up. But so I'm kind of focused on the OpenCV now, and this Pi Image Search guy is real good about dumbing it down for us beginners. And so he's kind of walking me through learning Python, like Murray was saying. It was a good excuse to do that. And teaching me how to use the OpenCV, starting from the basics and then getting up to doing something more advanced. So that's about all I've got. I'm going to open up this chat so I can put that web address in here.
That's pretty cool. Yeah, I think we have some others. If I'm not mistaken, Ray has also got some value from the Pi Image Search. Maybe a few others in the club as well. Okay, well, thanks. Thanks, Doug. So sticking with the Doug theme here, Doug P., is there anything on your personal side you want to talk about this week while we go around the table? Put you on the spot.
Okay.
There you go.
Yeah. Basically, I spent my week on the simulator, and I have. Well, since we're going to talk about it later, I'd rather talk about it then. Or wait a minute. I'll talk about the simulator, because that'll lead us into the rules, which I'll introduce when we start talking the other thing. Okay. Excellent. So you know, I went through Ron's code and everything, and it has a little bit of a problem in the sense that both Ron and Will were working on robots, and Will kind of bled into the simulator. Do you know what I'm trying to say? So, oh yeah. So, what I wanted to do is I took it from a point of view of what would we need to run a contest. So what I've done, and I think I've got it on a little. Let me present this little thing here, if I can get to it. Give me a second. Present. Okay. Try this. Share. Okay. You should see a Notepad Plus window right here. Can you read it? Is it too small?
It's a little small. If you did the wheel mouse and zoom up, control wheel mouse, you could make it bigger.
Oh, that's not working. Well, give me a second. Let me see if I can find out how to.
Well, can hold the control key, and if you have a wheel mouse, you can just hold the control key and scroll it.
Okay, let's try it.
All I see is a typical
Okay, here you
desktop.
go. Gotcha.
There you go.
All right. Okay, good. All right. So I've created a competition version of LFS. Okay, and it modifies LFS so that you don't lose any functionality. Even Will can go crazy. Yet it limits what a competitor would need. He only has to bring in 2 files, a user controller file and a user init file to run this thing. Okay, and then I also added for the computation version, I added a stopwatch feature. I added this was more for people. The next one is the single click competitor start stop functionality. So, because I'm thinking here, how it would work is everybody would ship their 2 files, and I have a naming convention which is in the rule, and we put it in what I call the pit area. And so then whoever's running the contest reaches into the pit area and grabs the two files, puts them into the simulator directory, and then runs the program. And he has it so where you can push one button and it starts, and the clock runs and everything, and then you can push the button once and everything stops, and the clock stops. So it's be very easy for somebody to run the program. Like I said, I added the pit area. I also, this is a feature that I added that would be more for people who are troubleshooting the robot. I added a single step jog feature. So I can let it run, but let's say you have a problem at one specific transition of frame for frame, not frame to frame, tile to tile, you start to have a problem. Well, you could stop your robot in its place. Then you could hit this single step, and you could single step it through it. And I've already found something that I was doing. I found it was also already helpful. I tried to add a backup button, but unfortunately, it's literally a backup button. It's not a retrace button. So I've left that undocumented. I added a single. Okay, I expanded the line sensor display up to 4 sensors. So I don't know if you remember watching Ron's version of the simulator, that he had a line at the bottom that showed you where the line sensors were, whether they were black or white. Do you remember that? Okay, I'll tell you what, I'll run the simulator and show what I'm talking about. But I've expanded that so you could have up to 4 line sensors and you'd have all the data there. I also divided the information panel. I don't know if you remember, but if you remember his original interface, if you had the panel on, it covered almost half the window. It was so big because it not only gave the robot parameters of speed and location and all, but it also gave how to use the interface. Well, after you've played with it for a little bit, you know the interface. So what I did is I split that apart so you can make the window go completely away if you just want a clean screen. Or what I find more useful is there's a little small bar at the top which gives you the position and the theta or heading and speed or the wheel speed or whatever you're tracking. Let's see. and then I added some. This is how I got wheel strike and similar type of robots, a little to retain their functionality, but yet not be in the other files. Is I added some function switches or stubs where you can in your user int file you can turn on certain options or turn off certain options. So those are some of the things. My next two things I probably look at. I don't know if I'll get them, but it was, man, I got to start playing with the robot now. Is I probably would like to get the sensor and robot data captured to a file. That would allow you to do some better analyzing things. You could spot patterns that you might miss. And then the second thing I want to do is on the spot sensors right now, that you see the location of the spot sensors, but you don't see the state of the spot sensors. You know what they are because you can see where they are, as you watch the image, but it would be nice to have an indicator that showed you, okay, this guy thinks it's a white, this guy thinks he's a black, So anyway, those are the things that I've managed to do. Now this link, I need to put it in the chat. This is the GitHub link for the simulation program and the rule set. Second here. Well, wait a minute. For people who haven't seen this, I'm going to go ahead and let's see which one do I have in here. Okay, I'm going to run a copy of the simulator so everybody can see it. Because I know there's people who haven't seen this. Okay, now this particular example does not have any line sensors in it. We could see, if anybody's interested, we could look at Ron's, which does the same thing as this one, but it just uses a different sensor configuration. All right. Okay, so here's the panel in its default. By the way, you can set this. You can either set it to look like this, or you can set it to look like this, or you can set it to look like this. This is my favorite personally. Now, so I'm going to pretend I'm in a competition. I have set up a default start time in my initiation file, so that when the judge comes in and he says, okay, we're going to start your robot, I've transformed your things. So he hits this button right here and it's off. Okay, so now it's running at, this one is 2 inches per second, and you can see it doing its thing. And you can see where it would be nice if you could have this area like turn a different color. Now, in this particular representation this is an example file that's included in the download, and these represent wheels. This represents the 3-inch circle for a 6-inch wheelbase robot, and this is the center of rotation right here and the axes. This is the timer over here. It's giving the actual position up here. And like I say, if you were recording this information along with sensor state, you would be able to get some useful data. So that's one of the things. All right, so everybody sees how this goes. I'm not going to run it all the way around. I want it to get to something though. All right, so I'm going to stop it. All right, now, so if I wanted to, I can do a little jog. See that? I don't know if you can tell, but it's jogging one step at a time. So this is the way it's responding.
step forward in one step of the simulation at a time.
Right, exactly.
Yeah.
Okay, so that's a feature I added. All right, so that's there are other types of sensors. This is just the one that I'm putting, because this is one that I'm using on my robot. Part of it. It's not all of them, but it's part of the sensor that I'm using. And I wanted to show people in the code how they could generate this very easily. Let's see, is there anything else? So like that's pretty much it. Oh, there is another view that's very useful. Here you can see the bread. Here's where we started. Here's the breadcrumbs, and you can see the path of the robot took. And this is a robot right here. So this view is slightly distorted from the actual squares because it's taking a rectangular map and fitting it into a square. But it's got all the useful information you need. So anyway, let's see. Everybody seen that? Anybody want to see any more? Or do you want me to stop it? You want to see another robot? Give me some feedback, guys.
Doug, this is cool.
I've seen enough.
I put a link for the. Oh, go ahead.
Everybody seen enough? Okay, we're going to stop it.
Yep.
And
I just had one question, Doug, because we'll talk more about the logistics a little bit later. But have you all these changes? It looks like you haven't pushed them out to the GitHub repo.
no, I didn't. No, I'm not going to touch the original line following simulation. I only think Ron should touch that. Okay.
I was going to suggest we follow, like, we try and adapt some more modern software practices. So I was going to propose that we take your changes and make a branch and push the branch out there. I see some people nodding on the screen. We'll push the branch with your changes. There's the metallic headband here. We'll push your all your stuff as a branch to the same repo, and that's how we can start the collaboration.
Okay, we can do that.
Yeah, I'll help you do that offline or after this if you want. But
yeah, I will say this, guys, I got the job done.
Oh yeah.
But my this is really the first time I've been playing with processing, so I'm sure it could be cleaned up and done better. So
that's all right.
Anybody
we'll do it in a branch for public review, and we'll decide where to take it from there. Because I think Ron has been working on some things in parallel. So
yeah,
by using a tool this way, we can help merge the stuff more cleanly.
Right. The main thing that I wanted to do, the thing that I was trying to do, was to answer the question of if we were going to run a competition, we had to have it so it was easy to do and easy for everybody to run. Why can I not see? Let me say, oh, here we are, back. So I wanted to make sure that I'm not sharing anymore, right?
Correct.
Okay, all right. So anyway, I just wanted to make sure that whatever version of the simulator we had, it would be one that we could run a competition in a smooth way. All right, and that's what I was aiming for. And so that's what that's for. Do you want to go over the rule set now, or do you want to hold that?
No, let's try and get around the table, and we have some members too that
all right
might have something to show. So
let me get me off here.
So let's see. Anyone else want to jump in? Something to share for this week?
Hey, this is Jen here.
Jen.
Since Doug just mentioned about the simulator, I want to. I looked at it. I have some ideas, so I just want to take this opportunity to Doug share something. So I looked at the processing, and thanks for pointing out where to download. I didn't know what it means, but now it turns out it runs right away. It's a good, very good simulator, and surprisingly, it's done like finished in August, so it's really recent. Anyway, I looked at it. I'm interested in running like, I mean, a camera. The sensor for me would be a camera. So I'm interested in collaborating in updating the code for the sensor, because my sensor would be different. I want to get a, let's see, 512 by 512 image out of that that viewing area, and probably I want to. So yeah, initially I looked at it. It's Java, so I'm thinking I would like to use OpenCV. It looks like there's OpenCV for Java, so I think the simulation probably won't share the same code as my real robot, but I think it's okay. So it's like just rehearsing the algorithm in there. But I'm interested in say, I mean, for example, we define an interface for the sensor, and we can have a different implementation for that sensor class. I mean, I guess it's similar to Java, so it would support these abstraction and different type of instances.
Gene, they have, like, I didn't show it, but there's something called a linear array sensor. And
yeah, I see a robot sensor file with several sensor class defined. So anyway, I want to say I would like to be part of this. I'm familiar with Git, so I can help you create a branch. I don't know what's the permission for that repo, but anyway, I think
the big thing we worry about, James, is if you sample, well, so I'll be quite honest, running 4 linear arrays and a bunch of spot sensors, I couldn't tell any difference on my computer.
Yeah, I mean, it's simulation, so I think we can make it like not sensitive to the amount of data it's processing.
Yeah, so what I'm saying is there's no reason why you couldn't say define an area like 600 by 40 by 480 and just sense them all. Now here's the real problem. You got to remember this is a simulator, and the real problem from what I've seen is not, well, I tell you what, there's a lot of value in this. If you can get your algorithms to run this, you got a chance. You got a chance of being able to run the real deal. Now, the problem with the real deal is the sensors are a lot more crappy than this one, where everything is perfectly white and perfectly black, and they're crisp. And I mean, it's a totally different ball of wax once you add lighting to it.
I agree.
If we wanted to make this a really realistic one, we would have lighting sources which would blur out the black, and blur in the black. But I will say, running the stains will give you some of that. We have in the challenge class, there's 4 or 6 stains, which if you can run through those without screwing it up, you would have it would be a little bit better. But I will say, like I say, I'm all for it, and I think it's not a problem to get on to make modifications to the code.
Yeah,
we can do that.
Yeah, this repo is a great playground. We can write something, push it there, let people critique or collaborate on a certain.
Well, I got to remember, I'm not a real software guy. So all of the team collaboration stuff like that, I understand how it works in concept, but I've never been on a big software team collaboration.
We'll get there.
I think Git is powerful enough to support many people. So, and by the way, is Ron in the group or still with us?
Oh yeah, he's still with us. He's just he tends to go to the monthly meetings, and he doesn't tend. Now, Will sometimes shows up.
Oh, okay, yeah. It'd be great if we collaborate on this together.
Well, the thing that I like about Will's robot, Ron's robot and my robot are both differential drive robots, which is about the simplest robot you can build.
Yeah.
Will shows you that ain't the only way to do it. Then his is a reverse trike. Now, if you have a trike model, you can also do Ackerman steering. Well, an Ackerman steering robot can be simplified into a trike. It's a simplification, but it can be done. And so with those two kind of models going along, it's real possible to cover a vast array of different types of robots. Now, like I would love to see Mecanum robot, one that goes this way, one that goes this way. That would be really interesting, because that would be, since the course is orthogonal and the robot's going orthogonal, it might be a way to enter each tile orthogonally. You know what I'm trying to say? Because with these other robots, they come into, you got to say a white black to a black white boundary, and your robot's coming into it, and it's coming into it cocked. Well, your sensor is going to give you all sorts of transitions and stuff.
Mhm.
So, but anyway, the simulator for straighten that stuff out.
So, I mean, I don't want to get into too much detail, but I think this simulation is great. It's a good demo, and it's a platform for more specialized. I mean, more personalized approach to try algorithm.
Yeah.
I want to be in the team to work on this.
Right.
The other part I want to mention is for the hardware I purchased. I want to get your opinion. It's like Amazon. I got like a $16 motor with encoder. So just wonder if that's something normal, like too bad or it's okay.
Can you hold it up?
Oh,
Yeah,
well,
how
I
big?
haven't got it yet, but I would imagine it's just a normal motor with a magnetic encoder behind that.
$16 for encoder, and does it have a gear ratio from the motor to the shaft?
Yeah, there's a gear ratio. I think it should work.
Sounds like a common
Great.
common price.
Yeah.
Okay.
Do you have it there near you?
Did I hear?
Do you have it there with you?
Oh, it's coming in tomorrow. I'll show you guys next week.
Okay.
I think the key, without a lot of knowledge of my own, is that will the motor be able to drive your robot the way you need it to drive? Is it going to be powerful enough?
Should be. It's a 12-volt motor, and I don't think my robot is huge either.
Okay.
So
Fine.
Carl, Gene, one of the problems we have had with some of the motors coming from like AliExpress and Alibaba, they're very good prices, but sometimes the encoders are a little flaky. So you might have to do some tuning by adjusting the magnetic sensors a little bit, and there's a couple other things that you can run into. And since they also use lead-free solder, because that's pretty much the standard for industry now, they can sometimes be really hard to take something apart and get it, to move it around in something. I can tell you, if money's no object, which it always is, but if it isn't, I would say go with Pololu motors. They're excellent. They're absolutely excellent.
what would be a nominal, like not too far, like a robotic motor with the encoder?
Well, I
expected
mean, how much
price.
they cost?
Yeah,
A Pololu motor is probably, I want to say $30 a piece.
30. Okay, double the price. Okay.
All right.
I've got plenty of these motor without encoder. So initially I thought I would buy an encoder, but I looked at it. I don't really know what to buy or how to attach to that that motor.
I would have to say that I recommend the Pololo motors, both the large ones and the really small, the micro gear motors. I've used both. I've on my robot been using ones from OSEP, which is I think a Canadian company, and that's what they look like. And they're 6-volt motors with encoders as a separate package you can buy. They're not cheap, but they're quite powerful. I can't remember the gear ratio, but I'll put the link into the chat here. But I've been using them for about a year now, and they're quite powerful. And I'm quite happy with the quality of both the encoders and the motors. But also Pololo is really good.
Yeah. Okay. Yeah, I'll look into the Pololo.
Guys, I've got another suggestion as far as motors with encoders and starter platforms for robots. I personally think Pololo is another great company as well, just not only for their selection and variability for their motors and encoders, but also Juan, I would suggest that maybe you look into one of their ready-made robot platform kits, either a kit or a
like the Romy,
or what? Yeah, like the Romy, or the 3Pi, that kind of thing that's out there, because that would be a easy, convenient way. Since you're a software guy, that would be an easy way to get the hardware out of the way, and then that way you can concentrate on your software development, algorithm development. And so in other words, for the idea about starting there and then start doing your own customizations as far as either using a RC car or building a 3D print platform, whatever you want to do from there. But I would recommend doing something like that. Even Parallax is a great starter platform kind of company to research.
My plan is I'll get one motor, verify that it is running, and my reading encoder is fine, and then I'll get like 3 more, and 1 for each wheel. I'm thinking 4-wheel, each has its own motor, should work. There was I had these kit before with like a track, so it's like 2 sides. Two side each has an active wheel, but the other wheel is I don't know how you call it. It's the track, right? Oh yeah, that's right.
Yeah, tank treads.
Yeah, I don't know if that's better. I'm thinking. Well, anyway, I think 4-wheel. I already put a frame there. I think it's easier for me to put 4 wheels on there. Each has its own individual drive. But just wonder if that's that's a good idea.
I got to agree with Donna on the Pololo platform suggestion, right? Ready-made. If you're a software guy, ready-made platform will get you. Sorry, my camera. We'll get you somewhere really quickly. In fact, I know I don't have a lot of lighting out here in my patio, but so you may not be able to see this, but this is a Romy platform. And you get everything ready to go. Again, sorry, I don't know how much you can see.
Yeah, I can see it.
It's got a Raspberry Pi Zero. You don't have to use a Raspberry Pi with it. It's got its own micro. And so it's kind of a la carte. You buy as little or as much of the pieces as you want, but they're all designed to go together. The white things are the motors here. The motors come with encoders, right? So it's a convenient way to get started. So
Yeah, maybe I'll give up my time now, but I'll show you guys what I have. Those are without encoder, so I got it in the box. Right up next to me. But yeah, thank you. I'll show you in a little bit my existing platform.
I think Murray, you had a box you were going to pull up to show your example a moment ago, that tracked robot.
Yeah, the only thing I can say about that was that I started with the OSEP tank kit, and I think the quality of it is excellent. There's nothing wrong with the quality, but my robot design was inevitably going to be a lot heavier than the original OSEP. And the first time I took it out on the carpet or on the floor, it turned and tore. It didn't tear, but the tank treads came off immediately. That it has to be a lightweight tank tread. If you're going to put a heavy robot on tank treads, it has to be designed for that. So I ended up using wheels, and the wheels that OSEP provides are these nice big silicon rubber wheels that go onto the same metal wheels, the tires, I should say. They go onto the same metal wheels as the tank treads, but they're much better. And so I ended up with tires. I don't know if you see that.
And I think we could probably have a really long discussion if we went down the rabbit hole of 3 wheels versus 4 wheels.
Yeah.
And I think we have too many people to start that discussion tonight, but I wanted to show one more example. This is a 4-wheel Mecanum one that I've got. I put a link for the vendor in the chat window here, but what's really nice about this version is that when you buy the chassis and the motors together, it comes with cables that match into these nice driver boards, and the driver boards are this is a 2-channel one for Arduino Uno, and then I've packed on another version of it, and this is meant for a 4-wheel Mecanum, and they have an Arduino Mega for that, so lots of spare pins.
Mm-hmm.
And what's really nice is that I think to Chris's point, when you get a kit like this where the mechanics are, I wouldn't say like in the way that you bolt after extra stuff to it, it's not perfect. The holes don't always line up, but the wheels, the moving gears, the wheel mounts, and the other stuff is really solid. And it's a good way to get started. And then you can duct tape it the rest of the way.
And if you want to go Mecanum wheels, I think I've showed these before, but I'm using the Pololu micro metal gear motors with an encoder on the end, and then these really nice stainless steel, I think they're stainless steel Mecanum wheels, and I've got 4 of these with encoders. So in terms of John, if you're thinking going Mecanum, this would be for a quite small robot, but these motors are quite powerful if you gear them down. That's another possibility.
Yeah, the cheapest way, if you want an encoder, this is the cheapest motor you can get with an encoder.
Yeah. But you were critical, Doug, weren't you?
I think I got that, but I don't. Okay, let me show you guys what I have.
Okay.
So this is one. So this is from a kit. I don't know if you guys see this.
Yeah, we can
this
see
is
it.
from a kit. I just cut it open. So it's like a small platform. So I sawed through it. So this is half. This is another half. This is a 3-wheel type, right?
Mm-hmm.
I got a. Oh, and this is probably one of. This is one of what we used for the competition. Call.
Oh yeah.
Now, here's the other one.
Yeah.
And this is another one of the same type, the one with the Bluetooth, also with the motor drive, 2-channel motor drive. And I'm thinking there's plenty of I/O here for the this modulated drive. I forgot the name, but like 3-pin with PWM. Yeah, PWM, right? So So this is the trad version, but I don't like it because it doesn't go straight, guys. So, and you see, I don't really see how I can attach an encoder behind it. So I'm gonna go by this directly motor with encoder, and I'm sorry, I don't know your name yet. My friend from New Zealand. I would like
Murray.
Murray. So I want to see. I see Carl has that type of platform, and the one you have is wheel. I got this frame set up, so it's like a few steel bars. I already made that years ago. So I want to basically attach 4 wheels on it, and then put this on there to drive the wheel, and that's kind of my.
You just gotta dig in.
Well, I can say that if you're going with that kind of aluminum frame, that OSEP makes a red version, identical in terms of size and everything. And so this is like I showed you a minute ago. The OSEP motors actually have a special little frame that's designed to hook right into the end of one of those beams. So if you're using, like I said, the OSEP motors are a 6-volt motor with, and the reason you can't attach an encoder to the one you have is you have to have an extended shaft on the motor for the encoder to attach to, whether it's going to be optical or Hall effect. And these have this little aluminum plate that the motor's attached to, and then you bolt into the end. And since you're already using that, I think either that brand, what is it, Make, I can't think of the name of the blue ones. Make Block. Either Make Block must have a motor mount, or you can go with OSEP. They're in British Columbia, I think. And they're quite nice people. They're fairly helpful. And their motors are quality. There's nothing wrong with them. So if you're going to go with that kind of frame, you could just get a motor from them with the encoder already. And there's nothing hard about attaching it. So
great. Yeah, I want to buy something easy to use. So yeah, thank you guys for the recommendation.
One last thing, Jay. If you decide to go to Pololu, do they sell a 20 millimeter, a 25 millimeter, and a 37 millimeter? 37 millimeter motor for a small robot's probably overkill, but I would go ahead and buy the 25 over the 20. It'll be more versatile for you when you want to reuse it on something. And you put
it's the size. It's the size of the meter.
Diameter. It's the diameter of the. I think it's probably the motor itself.
Yeah, it is. And the Pololu one, the OSEP ones are 25s.
Having just went through that 22 millimeter versus 20 millimeter versus 25 versus 37 millimeter search, guess what? There's a ton of 37 millimeters. There's a ton of 25 millimeters. On my little robot I was working on, they came with 20 millimeters, and guess where there ain't crap of? Okay, so that 25 millimeter, I'll plus one that all day long because I've since got the mounts for them right, hollowed out the holes correctly, and it's okay now. But there's a plethora of those, and even more so in the 37 millimeter ones, even though they're probably overpowered for whatever you're doing. You just got
a big motor, big robot.
Yeah, you got a lot more options.
Hey guys, so we have 16 on the line today, so it's a big night. I want to make sure we get around to everybody. Especially, we have a couple of new visitors tonight, and I was wondering if you guys are open to it. Maybe Robert, I see you got a robot-looking thing in the background. Would you be interested to introduce yourself and talk about your project? You're on mute, so you probably have to unmute yourself first. Huh. There you go.
No voice.
There's some sound indicator on your picture, but audio's not coming across.
Hold on.
Huh? I can hear you.
Forgot about that. There's a mute button on this thing.
It's all about plugging it in, isn't it?
I muted myself. I'm like, no, I got a really nice mic coming, a really nice pair of X12s. I told Beach, and I forgot there's a mute switch. So, anyways, how you guys doing?
Great, thanks. Welcome aboard.
Good. I think this is actually my Johnny 5. I own Johnny 5. So that's what this is. Johnny 5. You guys familiar with Short Circuit?
Man, that's
oh wow.
Man.
Yeah. So I own a Johnny 5. I have not built them, but I am fixing them and putting some electronics into them. And I want to. One of my goals is to make them animated. It's probably gonna use like a flow loop. Those I forget what the boards are called. Maestro's.
Sure.
Anyway, so yeah, I was gonna use that, make them a little more animated. He does move. I haven't turned him on in a while. I've been home recovering. I had heart surgery 3 weeks ago, so slowly but surely getting my focus back and getting back into projects and building things. I'm working on an RTD2 and an RTD2 builder as well. So that one that I actually am building. So the Johnny I acquired. He's owned by Jay Overwood. So somebody actually posted on my Instagram. Somebody posted a picture with my Johnny 5 like 30 years ago. So I happened to come across, they tagged it Johnny 5, and I looked, and I'm like, holy crap, that's my robot. So I talked to the guy, and he's like, yeah, I took this back. This was taken when I was a kid. So I'm like, wow, and I said, that was applied back in the 90s. So that's how old he is. So. But one of the other projects I do well is the, you guys probably know what this is, the Back to the Future remote. That Doc used to drive the time machine. Me and my buddy, we build those and sell them as replicas. We have 3 versions, actually 4 versions now. The Class C, which is basically just any old remote. We put the display on it. It lights up and says 88. You know, a couple little, so it looks like the remote. Then we get, as the price gets higher, it gets a lot more accurate. We do have it count and have the sound. I built a sound chip. I do all the electronics in it. So I do. I use the high end are using the Spark Fun sound chips because they have like 18 triggers on them. The mid range we have about, I use about 6, but I believe there's 10 on there. I only use 6. So, but yeah.
So if we put enough gigawatts into that remote controller, can we go back in time?
Yes, we can. Yeah, and I'm actually a member of Star Cars out here. I'm in California. I'm not sure where you guys are at, but I'm in California, and I am Elwood Blues. I'm the Blues Brothers. So if you ever see a couple of guys around LA, or even you can find us on the internet really easy. Just type in Hollywood Pacific Blues Brothers. It's always me. I'm always the first picture. So far, it's been that way for a few years now. But we have time machines and everything with Batmobiles, Michael Keaton version, the 66, Adam West version, A-Team, you name it, we have it. So yeah, a lot of cool Star Cars. So and fortunately for COVID and plus my surgery, we haven't done anything this year. It's been very, very limited this year. But usually every weekend we're doing something charitable, and I usually bring my Johnny out for stuff too as well. That's me in a nutshell.
So on the Johnny,
good.
On the Johnny, is it made out of plastic, metal, or how is it built?
It's metal.
Describe it a little bit.
Easy. He's metal. He weighs probably, I haven't weighed him, but I know he probably weighs just south of 200, maybe about 50. I need to weigh him, but he's cumbersome because the center of gravity is actually not really expected to be. And I usually take the head off when I move him, but few people can lift him up. And the problem is he's a little cumbersome. He's heavy, but he's not like, oh my God, heavy, but he is all metal. Give me a second. I'll turn on some lights so we can see him better. 1 second.
So Robert, do you do this as you're not a headset anymore?
But while he's walking around, one of the traditions, I'm trying to remember the movie because, it's been a couple of years back. There were 2 of them, actually. So I'm trying to remember if it had treadmills on the bottom or tracks. I'm thinking they're tracks on the bottom.
It's tracks. It's tracks. So I'm having a little trouble seeing myself in that small display in the upper right. But so I'm not sure exactly what you guys are looking at. But, all right, so there's his head.
Totally different.
And there's his torso. And right in the middle, all those boards in the middle, which are kind of hard to see, are all practical. They actually control them, but it's all very old 90s electronics. And I started to buy electronics. I was going to focus on new electronics for them, but I found out I needed surgery, so I just stopped. I didn't even bother buying stuff. I got to get past this surgery and then I'll pay for it. So he's been sitting in my living room. And here's I put a new sound system in him. I'm actually working on another one. And then there's his tracks right down there.
So wheelchair motors drive the track?
No, actually, you know what? They're these huge monster. I believe they are. I'm not sure, but I'm pretty sure. I was talking to a buddy of mine. He said he's pretty sure they're DC shunt motors. So old school stuff. Pull a lot of power. So I have, I believe, some just regular, because the gear ratio on the track drive is 1. So he's really easy to move by hand. Just grab it and turn it, and the tread will start moving, no problem. But with that, because it's 31, you really have to kick up the RPMs just to really want to go anywhere with any kind of speed. So
Wow.
But yeah, I was bored one day. It's like, let me actually count this, and I was at 30 to 1. I'm like, wow, it's a pretty good ratio. So, but yeah, the motors in our arm are 26 RPM. They almost look like alternators. So, yeah, it actually gets pretty tall. So, hopefully I got battery power. A little more of a walk around. Get up here. Like I said, he's taller than me.
Could you remind us which movie was you in?
Short Circuit.
Short Circuit. That's it. Thanks.
So, yeah. And yeah, maybe you could see. If you guys can see that or not, I can't see the screen, so you have to talk to me.
Oh wow.
You want to go left or right or anything?
You're right on the motor.
Yeah, and that's the motor that drives.
Forklift motors.
Yeah, they're huge, and I'm gonna pull them out. Get some standard DC motors. I have a Sabertooth. I think it's a 32 amp Sabertooth. There's a soundboard. I don't know if you can see that or not, but that's a soundboard back there. So yeah, so there he is in all his glory. He is tall.
Robert, thanks for showing us. That's pretty cool. But just a question. So we're all here in Dallas.
Here's my R2 real quick.
Oh yeah.
R2 or not? You see that? Yeah, this is my storage area for all my R2 parts. And slowly but surely, got some. I'm not, like I said, I'm out in Cali, so we have builder days every now and then. But because of COVID, they really limited a lot of that stuff.
The Dallas Makerspace has somebody who's in the R2 Builders Club. So.
Yeah, Glenn Pike, aka Alyssa Pike.
Right.
Alyssa Pike. But Alyssa used to be a DPRG member. Hers is, I guess it's a full size. In fact, yeah, it's got to be a full size robot. I mean, the thing stands about 4 feet tall, and it's all metal, and it is not autonomous. She has to control it with an RC controller, but she's got all the skins and everything. She usually runs it without the skins so people can see the insides, but she does have the skins for it. It's a really beautiful robot.
He described running up to some conference and getting one of the Star Wars people to sign the inside of it.
Yeah, you can see it in performance if you go back and look at some of the Robораmas that were done at Barrow Museum you can see it in action. It's so it's available on the DPRG Clips. That's the YouTube channel.
Cool. Okay. Hey, so interest of time, moving on. So hopefully I'll get your name correct, but Saurabh, are you still online with us here?
Yeah, hi, Carl.
Hi, welcome.
Yeah, hi. So I visited you guys at the Makerspace, I think last year, because this year is all gone.
Right.
Yeah, so I was trying to that time make that autonomous robotic hand doing the pin pad payments, like swiping and inserting the card and then, typing the pin and doing the signature for autonomous testing.
I remember that. Yeah. How's that project been going? Did you make any progress on it? Or are you doing another project now?
Yeah. So it's good that you remember. So yeah, I have completed that, and I think I've made a video. So I'll see if I can share it here. Just give me a moment.
Yeah, sure. Yeah, so from my memory, for those, while he's looking, he had brought by a box full of parts, and I think he had one of the multi-jointed arms with the servos at each joint. And I think, if I remember right, correct me if I'm wrong, but if I remember right, the whole concept was to have a tester for a credit card automation payment system kind of a thing. So the robot would Go ahead.
That's correct.
So the robot would move the credit card in and out of the reader and allow quickly testing how the reader was working. And he was talking to us at DPRG, the makerspace, for different ways to solve different problems associated with that.
Yeah, that's correct. So
Any luck with the video, or would you like a few minutes? Should we bounce over to someone else while you find the video?
yeah, I do have. I'm just I'll start I'll start sharing.
Okay.
Yeah. Hi.
Hello.
So this was this was the hardware with which I started, and since I completed the project, I have yeah. Can you see the screen?
Yes.
Very narrow.
Yeah. So this was connected to Java, Selenium Java automation. So as soon as we get a trigger to do the card payment, this will slide in the card and do the pin pad. So this is just like I just wanted to make a 1 minute video. So yeah, so that was insert, and this is like tapping the card, so you can have multiple cards. So it was not very precise to pick the card, so I just attached. Yeah.
Wow, you made a lot of progress.
Yeah, thank you.
Yeah, it looks good.
Reminds me of the wafer cassette. We used to work on these automation tools to pick up wafer.
Do I remember that you had some challenges with the management to get this approved, and then you managed to see it through?
So that is the part I could not. So yeah, eventually they wanted to have something pretty fast. So I thought, okay, this is a good learning experience for me, and that's where it ended. Yeah,
that's
but
great.
yes, but during the course, I learned a lot. Yeah, so during the course, I learned a lot, and this is I had Arduino, and then these are like serial servo motors, and to solve, there were many challenges to make the card replaceable, so that I can change the credit cards if I have to insert. So I used magnets to solve that problem. So this is like the test bed on which I can place my credit card, the test card which I have to. So I can place the card on top of it. Let me just grab something. So placing the cards was a challenge, so I used the magnets. So like this side and both the sides, neobidium. So it moves on uh, a motor. This is like what we get in a CD drive. So that I just took from there. And then the motor driver. So this is like a stepper motor. These are the stepper motors, and the stepper motor driver, which is connected to my Arduino. And then I was doing serial communication with my PC. So that was and that was like TX and RX both. So and then there was a TX and RX to the ARM. So yeah, and this is where we had our pin pad, so we can swipe, we can insert, and then we can have a stand over here where we were able to pick up the cards and tap on the screen. So the main purpose for this was automation to test the POS application. So a POS application is pretty much what we see in Walmart or Target. So to test that software with the pin pad, it was like we were having a challenge where we were getting stuck at the payments part. So with this solution, at least I was able to automate the testing complete end-to-end 100%, where the software testing was the automation software part was done by Selenium Java, and then it was able to communicate with this, and it was doing the credit card payment, and then I was able to continue with the rest of it. So this was my mini project. And thank you all the support from Carl, and I remember Ray, who helped me then. So thank you.
You're welcome. That's good. It's cool to see that that you got some good progress with it. Something to feel really good about.
Yes, absolutely. It was really good. Thank you.
It's not a single step overnight kind of fall off the table easy kind of thing to do either.
Yeah, I went to Home Depot and then I searched a lot. I had to work on the board and fixing it and everything and all these cutouts. And for everything which breaks, we have that Gorilla Glue, which helps me. So, yeah.
Cool. Okay, well, thanks.
Super.
Hey,
Yeah,
in the
thank you.
interest of time and super glue there for Ray. So in the interest of time and so many people online, can I just get a show of hands? Who else has something to share this week so we can allocate enough time for everybody? 1, 2, 3, 4, 5.
I have something.
6. Kareem. Okay, so we have 6 people and a little over an hour and 20 minutes. And we actually have a 7th topic, meaning the November contest planning. So maybe if we take 5 or 10 minutes for each of those of us to have to say something, maybe 7 minutes, 5 to 7 minutes, okay? So Murray, do you want to go next?
Let me just, yeah, sure. I'll just, for those who don't know, I've got I guess you call a mid-sized robot, which I'll try to, I'm not sure if you can see that. Is
Looks
that
good?
clear? Yep. So I've put a mast on it now, and the BNO 055 that I had is up on the top of the mast now. And as I've described previously, the problem with that, of course, is that it goes out of calibration quite quickly, on and off. And so I've gone ahead and I had an NXP 9 DOF board from Adafruit, which is actually a combination of accelerometer, magnetometer, gyroscope, and something else. I can't remember what all is on that board. But there's a guy who has like 99 PhDs and works for the Air Force named Kevin Walchko, who's written an NXP IMU library in Python. and I'm trying to use it, and I've tried getting in touch with him. He's just about impossible to get in touch with. I'm getting all sorts of, both from the BNO 055 and from this NXP 9 DOF or whatever it's called. I'm getting all sorts of, I basically am in IMU hell right now. That the maps are way beyond me. And like on the BNO, I can't get anything below 12 degrees. Like if I aim straight north, I get basically 12 degrees. And I used to get 0. And I even went back to old code. And then on the new IMU, I'm getting basically values that look like 0 to 2 pi, but when I actually try to interpret that and actually rotate the robot around, I can get a 0 degrees and a 360, but as I go to 90 degrees, it shows at 180, and then it all of a sudden swipes all the way around to 360. So obviously the maths are wrong, and it's not even my library. So I've spent the entire week on this, trying to figure out how to get
Murray, that sounds like you've got a sine issue. Because it's sine and cosine as it goes back and forth. That sounds like because I used to do a bunch of 3D graphics and coding all this stuff from hand. And I will guarantee you what was happening to me with that very same thing was because every now and then the sine and cosine will go negative in a very predictable, but if you don't expect it to happen, you're going to get the wrong answers. And that sounds exactly like the kind of answers I was getting wrong back in the day.
There's even a comment in Kevin's code that suggests something of that. And like I said, I had differential equations in university and trig and everything, but it's 25, 30 years ago. And I am just, exactly. Thanks, Ray. It's like, forget it. And I'm just so tired of IMUs. I just want to get a compass heading. It's just, one number. And so that's what I've been working on. I mean, the robot's kind of done in terms of the core functionality, the hardware. And I think I might have mentioned that I replaced my entire front. Pick it up again. This entire front section of the robot is 5 infrared sensors and 3 bumper switches. And I've replaced that little itsy bitsy right here with a IO expander board from Pimoroni, which is about twice as fast and is a lot easier to interface. And now I've got 2 IMUs in the robot, and I'm trying to basically compare the outputs of them. But everything's kind of working hardware-wise. The software is getting to be really tricky. My goal is basically to be able to say to the robot, go north or go south. And it would, if I say go to the north side of the house, go to the south side of the house, that's my first task, is to say that. And if I can't get a reasonable compass heading, forget it. I did note that the BNO 055, even when it goes out of calibration, the quaternion that it returns is still relatively stable, although it won't go to 0 degrees for some reason, and I can't figure that out. But I'll probably take it onto the mailing list because this is obviously a very large topic. But that's where I am in IMU hell. So,
hey, Murray, could you provide the that library link
sure.
In the chat?
It's all in GitHub. I'll go ahead and send the link.
Thank you.
It's in Python and GitHub. But that's it for me. Oh, David.
Can I jump in and offer a modicum?
Yes, please.
The IMU that I'm using on the RCAT robot, which you've seen run, and which is pretty accurate. Now, I have to offer a caveat, which is before I got that working, I had odometry, just raw odometry, working real well. So then I had something that I could then reference against when I was tuning the IMU. You see what I mean? It was my ground. But here's what I ended up doing. After working my way through that for about a year, I kept reducing the amount I was getting from the IMU until I finally just went to the raw Z-axis gyro.
Oh.
All right. And it turned out that the raw Z-axis, now it's a rate gyro, so it doesn't give you a position. It shows you how rapidly you're turning. So in terms of odometry, that's basically the same thing you measure with odometry. You measure how rapidly you've turned and you integrate that. And when I compared the two of them, once I got them scaled right, they were remarkably similar. It actually stunned me how similar they were. It's a little bit heat sensitive, temperature sensitive, But other than that, it's there. Okay, so then all I did was integrate that value. If I can send you a graph where I compare the wheel odometry to just the raw sensor and that Z-axis rate gyro, and they're very, very close. But what you see, and what you'd like to see, is that especially at sharp maneuvers and stuff, the gyro is giving more amplitude than the wheel odometry does. And then, of course, if you do something like pick up the robot and rotate it 90 degrees, the rate gyro sees that and the wheel odometry does not. So if you generalize that, that means when you run into things, the gyroscope is more accurate because it's actually telling you how the thing actually wiggled rather than what the wheel thought. So basically, I just integrate that value from the rate gyro, and I found that gives me an excellent heading.
Okay. Well,
I just dropped the rest of the IMU. I was like you. I couldn't get it to work well enough to be useful.
Well, as before, I appreciate your advice, and it does kind of push me back to getting my PID controllers and my odometry finished really before I go on to a compass heading. I might have been, again, unfocused and not working on the thing that really needs to get done first.
I don't know. I appreciate that because if you can get a good IMU heading working, that just makes everything. The odometry can be sloppy after that because you can fix it on the fly. But for me, the way I iterated to that was by using the odometry as my ground truth in order to adjust the IMU. And what that eventually led me to is to use that expensive IMU as just a Z-axis rate gyro.
Okay.
Oh, I don't let it screw with it at all.
Well, until I somehow broke it, which I can't even figure out how I did it. Maybe it's a hardware break, but I actually used to get the BNO 055 when it was calibrated to actually give me a very good accurate heading. I mean, I put a compass in front of the robot and rotate the robot, and it was within a few degrees. And if I was willing to say, okay, I won't take a calibrated value, it was still pretty good. But then I've done something and I've busted that. And I'm not sure if that's the hardware or software. I haven't changed the software so far as I know. But anyway, I don't want to take too much time, but yeah.
You have to be prepared that compasses don't work very well indoors because there's just metal around pipes and concrete rebar in the floor and all this sort of stuff. And so the hope is that the rate gyros will correct that, that if you have a good Kalman filter, the rate gyros will compensate for the fact that the compass is drifting around. My experience is that in practice that doesn't work because it can drift. You drive by a big iron object and the compass heading will shift 90 degrees. And that, that's not a little error that you're trying to correct.
Oh, no.
So I found compasses work great outdoors. Really, really.
Well, putting mine up on the mast actually made a big difference. And until I got to the point where I somehow busted this thing where it won't go down below 12 degrees, which I need to fix. But anyway. So, and to Donna, before I say so long and let someone else go, I'm just going to hit the yes on posting there. I've just posted the GitHub link. And I can, if you want on the mailing list, we can discuss what this is. There's there's quite a lot of files in here right now. So anyways, that's it for me.
Thanks. And there you go, Donna. That's the code for Murray's IMU stuff. Okay, so let's see next. So Mr. Anderson, did you have something else? Like, forget who all rose their hands now. Were you in that cloud of nothing? Okay, so let's jump over to Harold. I think your hand went up, right?
Okay, I'm going to go fast. First of all, I'm going to start with the really sad news. Is that, OBS going over here. I was going to get rid of my Roby Senior Hero tonight. If anybody would like the Roby Senior Hero, you can have it, and we'll figure out how to get it to you. It's been hanging around. It was given to me in this condition. I've done nothing with it. It's been sitting around wanting me to do something with it for almost 20 years, because that's how long I've been living in this house. And it was sitting here staring at me, and I'm going like, hey, why don't we give this to somebody? And as soon as I think this is way cool, somebody shows up with a real live Johnny 5. And I'm like, what the hell?
What state are you in?
I'm in Dallas, Texas. DFW.
Oh, okay. Yeah. Shipping would kill me.
Shipping is going to be a bear for this thing because it's all nice and heavy, and it's made Radio Shack way from 1978 or something.
Yeah, I would love it because I'd get them to do something. Yeah.
I'll take it.
Who wants it?
Doug.
Doug? Which
Yeah.
Doug?
Doug P.
I don't see you on the thing.
Darcy.
Oh, yeah, okay. Doug
I'll
D.
probably up around.
Doug D. Okay. Doug, ping me afterwards or whatever.
Whatever.
Tell me how you want to get this, and it's yours. Okay. Hey, there's even I'm not trying to sell it, but there's even a cassette tape still in the cassette.
Yeah.
Oh.
I don't know what's on it. Never played it. Don't know. So, okay, as I got the camera in my hand,
Probably gone.
this is what my robot looks like now. I managed to mount my Latte Panda with the Latte Panda thing in the front of it. It's mounted on. I'm starting to wire up the motor controller and put that in the right places and that sort of thing. Been making progress on my Twitch channel if you come around and see that. I'm trying to go really fast. What I need to do now is wire in. This surprised me. Wire in that. That is a 5-volt, 5-amp buck converter. That's what it's rated at, 5 amps. That little thing, 5 amps, I find it difficult to believe.
Yeah, me too.
But that's what it says it's rated at. And it did say if you're going to run it at 5 amps, please put a heat sink somewhere on it. And so I've got some of those laying around. So I'm gonna 3D model a holder and put that down in the basement with the rest of the power gizmos that I got thrown here. And speaking of power, I found this the other day. These cool things are called lever wire nuts.
Yeah, those are cool.
And I didn't see them before. They come with a little thing where you can get them in kits where it's got a connector on them. You screw that in, and this does a really nice, solid, firm click on it so it holds it. And this particular model will take anywhere from a 28 gauge all the way down to a 12 gauge wire and hold it securely and hold up to 32 amps.
Wow.
And so I'm planning on this robot here to run all of my grounds to home and all of my 5 volts to home, so I don't have any of that drifting. I get a broken ground somewhere in the middle of all the mess thing going on there. I'll wire a little bit more, but anyway, those are the plans. And this is the kit I got. I got a few of these. I may use them all around the house. I may put them in my car. I don't know, but I'm going to do a bunch of them. Let's see what else I got going on. Oh, I got one other thing. Actually, 2 other things. I built this thing, and this is coming on my Twitch channel. This is my Magic 8 box. Like Magic 8 box. Is this the best DPRG meeting ever?
Would you like fries with that?
Okay, so it's not that great. Can you give me another answer?
You don't need that in your life.
Oh, see, they're mostly disparaging things that I've recorded and put on the thing. And so on my Twitch channel, I'll eventually do something with that and have people do something in Twitch.
You may want to rephrase that question.
Hey, I didn't push you that many times. Okay, but anyway, the actual real question I had last week I didn't get to ask because we just simply ran out of time. I've been upgrading my 3D printer. I put a MOSFET on it so I don't have to run all that power through the board. And I found out something really weird. And I think I know the answer, but I need somebody that knows more than I do about MOSFETs. I'm watching. I need to do high amp current, and so that's a 10 gauge wire. 1 foot of a 10 gauge wire is about 1 milliohm. So if I do the voltage sag over 1 milliohm, that gets me amps showing up on my, so I can measure up to 50 amps with my 10 amp meter, doing the voltage across that, right? And so I was checking my amps on this thing because the MOSFET was getting really hot with the PC power supply. The normal LED power supply, it would go okay. It would do just what it's supposed to do, no problems. I wanted the nice power supply so I could turn it on and turn it off remotely. When I'm tracking it with this, the PC power supply actually provides less current, or at least my meter measures less current. but the MOSFET gets hot enough I can bake an egg on. I haven't burned it up yet, thank God, but it burns it up. So I've got a guess, and that guess is my PC power supply is switching, and it's switching on and off fast enough where the MOSFET isn't turning completely on, and so I'm getting a lot more resistance in the thing than I should have. Am I close or not? Any ideas?
Yeah, it depends on what the RDS on is for the MOSFET and what required gate voltage, to get the thing to turn on.
And I didn't do all that research. I figured it would just work. And now also the research I did do a little bit says something about the frequency that it hits it with and that kind of stuff. I've got to be careful with that. And I have no idea what the PC power supply does. I just hoped it would just work. And
we ordered Harold and I ordered a Kickstarter for it's these little Bluetooth oscilloscope things, and if they would just deliver it,
man,
you could use that, Harold, and you could measure it and see.
We did get an update on it, about a week and a half ago. We got some email, and they are supposedly starting to manufacture some stuff.
Cool. We might see it this
October, maybe October, I think.
You might see it this year. Yeah, I'm going to post a link into the chat. Harold, I put an Amazon link for the wire. I don't know if it's the same one.
Yeah, I haven't got a better source than that, than the Amazon links, because that's where I bought this stuff at.
So if you could put that link in, that'd be great. And then I put another link in for it's a little panel meter. Oh, this particular one's out of stock, but there's a lot of knockoffs. It's like $10 or $12, and it has volts and amps up to 10 amps. Here's one for $10.50.
Yeah, I was afraid to hook my meter up to this because that PC power supply at 12 volts is rated at 50 amps coming off that channel, and my 10 amp meter is not going to hold 50 amps. I know that much.
Yeah.
That's why I came up with that. I got a little YouTube, got a little inspired, and I said, wow, 10 gauge wire, a foot of it is a milliohm. Milliamps go across it. Oh, that gives me I get millivolts across the milliohm, and those milli things cancel out, and so I get an amp reading on my voltmeter. Math is great. Math and science is awesome.
There you go.
Harold, the fact that your MOSFET's getting hot suggests you're not turning it on.
I'm not turning it all the way on.
You're not turning it on fully.
Yeah.
And that's what. So otherwise, the whole secret of those type of MOSFETs is to turn them on hard, and that's so when they're hard, then there's no voltage actually dropped in the MOSFET per se. You follow on?
Yeah, I was.
So if it's getting hot, that means you're dropping voltage on the MOSFET itself.
Yeah, so that explains why I'm not pushing as much current as I thought I might be pushing when I'm reading that thing. When I'm reading the current coming through the PC power supply.
So you're essentially upgrading the power supply for your 3D printer hotbed. Is that what you're trying to do?
Yeah, and well, two reasons. I wanted to do the whole thing because I get standby power with it, and the Raspberry Pi and Octoprint knows how to trigger the power on, power off button on the power supply, and it's always on, so I could start this thing remotely and do all those sorts of things like that. Because I get my printer set up, I get it pretty trustworthy where literally I'm changing filament, and once I got a roll in here and I'm good with the filament, I can say start the thing and walk off and trust it to know that it will do all the right things, and because I've got the bed leveled and all that kind of stuff tuned in, right? Which is, I know you're laughing at me, and everybody should, but if you work with it and you build it enough where you trust that it's going to work, then you can do that. Most of the time, plastic goes where you want it to, but not all the time.
I always kind of stay in the area until I see the first layer laid.
Yeah, first layer. Yeah,
once that's done, Octoprint is just, you look in the camera and say, "Oh shit, it's screwed up."
I was going to say you do want to check every so often, because the biggest problem with those 3D printers is that they tend to come loose, and then you'll get this blob of plastic.
I have had plenty of blobs.
Yeah.
Okay.
Yeah.
So that's the bitch.
Yeah. So anyway, I think that's almost my time. But Doug D, you're the one that wants to. Robbie, I'll put my email address in the chat, as well as a link to the Amazon stuff I just bought. The lever wire nuts is what they're called.
Cool.
Okay, great.
Thanks a
Email
ton,
is
Harold.
Yeah, cool.
Pretty awesome. Thanks.
Yep.
Okay, let's swing around here then. Hey, Jack, I forget. Did you have your hand up tonight?
Oh, okay.
Yep.
Can
Here
I
we
jump
go.
in?
Who's that? David,
That's
yes.
I just jumped in. Just to follow up on Harold, I don't know if you guys know of these things that the radio control people have solved a lot of problems that we also have, and one of them is these connectors. And I think I showed you before. Are you guys familiar with what they call DEANS, D-E-A-N-S connectors? They look like this in the package.
And they're low resistance connectors.
And they're spring loaded, and they're polarized, and they're really small. They're just great for any kind of high current loads. They also make a miniaturized version of them. I don't know if you or not. Which I use over my robot if you're below 10 amps or something. They're inexpensive. They're really robust. They have great cable support. And anyway, I highly recommend Dean's connectors. So
I'm currently standardizing on XT connectors. So these are some XT30. So
yeah, that's why I these up.
You know, male, female, buy them in packs of 10, and they're supposed to be good to 30 amps. Although, if I'm pushing 30 amps to that, I think I got other problems. I think I'm pushing to that.
Cool. Mr. Jack.
Oh, yes. DEANS, yes. I don't seem to be able to.
Yeah, so I think last time I talked to you guys, I had gotten the competition robot pretty much done, but I've got some glitches right now. And one of the big glitches is, for some reason, when I turn it on, it works, and then if I turn it off and back on pretty quickly, it doesn't work. And I've hooked up the oscilloscope, and it doesn't seem like there's any current in there. But I wasn't sure if you guys had any ideas.
Could you remind us on what was the circuit that you're talking about, or the system?
The competition robot for the 6-can.
And then, but which part of it?
That part I'm not really sure, but the whole robot doesn't work when I turn it back off and back on.
A loose connector.
What?
Loose connector. If
What do you mean by that?
If it's connecting, maybe it's something loose. I had a wire that kept pulling out for no reason. It was a little tight, and I had to look through and find it. It was on my 5 thing.
Mm-hmm. Yeah, I thought I checked all the way through that, but maybe that is what it is.
So you're turning it off and then back on quickly, and it doesn't.
Yeah, it seems to be if I wait long enough, it does work.
Yeah. Sometimes there's like for resets on processors, you know, it's supposed to go down below a certain level. You may have some, you know, who knows, charge on a capacitor that's keeping the voltage on the micro up, and they also are supposed to have what they call a monotonic rise, so you don't, you know, you're not supposed to go like, you know, the voltage is, you know, supposed to increase and then dip down and then increase. So monotonic is it's always rising. Sometimes reset circuits do that. So, you know, it may take a little time just to fully discharge everything to charge it back up so it does reset correctly. So
there's a little gadget that Ty makes that his whole purpose is to wait for the voltage to come fully up before it'll basically reset the microprocessor. Can't remember the name of it now. This looks like a transistor. But to solve that very problem with battery-powered devices, you don't get nice smooth edges when you turn things on and off. They, you know, it squares that up for you. If any of our TI people know what it is I'm talking about?
Probably just a micro reset circuit.
Yeah. I know specifically for that. I've been so far out of the current ones, but I used to use a voltage comparator. So it was an op amp that would trigger at a threshold, and you'd set the threshold to a little above the lowest minimum voltage that any of the chips on the circuit needed to run, so that if the power supply, even for a brief instant, dipped below the lowest voltage that any of the chips needed, the weakest chip needed to run, then it would reset everything and bring it back up again. But one way to check that is that maybe you have a dropout from the connector, maybe you have a low impedance, a high resistive wire, so it's dropping voltage when the current goes through. So one way to check that out would be to hook it up to the power supply, make sure the current limit is set high so it can provide as much current as you want it to, and then if it's still dropping out, then you got some other, and then at least you could use the voltmeter and kind of trace through and see, where you're losing voltage.
Okay.
Yeah, there was
All right.
there was a story that I think this it's pertinent here. I was waiting in line at the DMV, and this woman in front of me had her child with her, and he was hanging on. He was I don't know, maybe 3 years old, and he was hanging on the little rail in the entranceway there. He said, "Mama, this hurts when I do this." She said, "Well, don't do that then." So, it's like the don't reset it quickly.
And then, do you guys have any idea when we might be opening up?
Sorry, what?
Do you guys have any idea when we might be getting back together at the makerspace?
Yeah, I haven't been following. John, do you know the current rules these days?
I really don't know offhand. I know that they've had, a couple people meet group wise, but they haven't really had any class per se there as far as like 4 or 5 people maybe, like for the machines, where they do some training type thing, but relatively small groups, individual.
So what we probably could do maybe is like Jack, if you wanted to meet sometime, we could probably arrange, and just 1 or 2 of us could come in and we could sit down with you there if you wanted, for example. That could probably work.
Oh, it wasn't anything specific for me. I was just ready to get back together with everyone.
Okay, Dave has something for show and tell on his screen. And he's not going to share the virus with his robot either. No, he doesn't have anything to show.
No.
Okay. Okay, Jack. Well, hopefully that helps. I don't know if that does or not, but
okay.
Tracing down those problems is always a pain, especially remotely.
We might want to do like an outdoor type thing. We probably could do something like that in a couple weeks or that.
The thing I found frequently is that it's just a loose wire somewhere.
Okay. Yeah.
If only it would jump out and say, "Hey, plug me back in."
Yeah.
Yeah, right. One of those 1,000 wire connections.
Yeah.
I have some
All right, thank you.
And it had to do with the fact that the battery-powered supply, when you flipped it off, faded off. It didn't go off quickly. So it's actually, this exponential decay because there's some capacitors in there. And even some little tiny residual there was enough to hold some of the circuitry up. So that when you rebooted the thing, it came up weird. And so if that's what's going on, a quick test would be to turn the thing off and wait a while, be sure it's totally off. You might even short any handy capacitors to ground just to be sure everybody's at 0, and then turn it back on and see if it still does that. I have seen something very similar to that, and it had to do with the fact that, as I say, when you power it down, Even though it's off and the LEDs are off and everything, there is a little tiny amount of charge there. And it's enough to keep some things up and running.
Yeah.
Okay, I have actually waited a while before turning it back off, and that does seem to work. But I guess I wasn't sure why, though. So.
You know, that exponential decay actually never does go to zero. You know,
That's right.
It goes up to infinity.
Well, yeah. One thing you might try is you can figure out how big is your 5-volt supply. Are you using what's your voltage supplies that you have available? What's your battery on it?
So I've got a 12-volt battery, but it's all running through a 5-volt power supply, 2 5-volt power supplies.
Okay. One thought would be you can take a resistor, okay, and put like a 12 k ohm resistor from the battery to ground, okay. So that's going to pull 1 milliamp through that resistor. So it wouldn't hurt to don't have an 1/8 of a watt resistor. It should be a resistor that's got a little bit of wattage. I guess you guys can help me out. Let's just see, it's 1 milliamp times 12 volts. How many watts is that? 12 milliwatts? 12
It's
milliwatts?
just a slow drain, but that approach, presumes that, that used to work well in the day, Doug, when you just had a single rail for all the chips.
Yeah.
But on our circuits these days, when you have, one battery and you have umpteen power distribution things within a circuit card.
You probably don't have that. You probably have two. You don't have to worry too much about the one that's on the microcontroller board. I don't think you will have to worry about that. But you would have to worry maybe about one that's supplying to the microcontroller board. Okay, so if that's a 5-volt supply, you can just have a bleed-off capacitor, a resistor between that, and that would work too.
Okay.
And I mean, it's not going to make it. All it's going to do is speed up the decay. Everything that these guys have told you about it decaying is true. I mean, it's still there, but this puts a load on it that defeats the high impedance that you might be seeing when you turn it off.
Okay.
I mean, it's an idea.
Yeah, and you said a 12 kilo ohm resistor?
Well, no. Well, I'm thinking this back. I don't know you. Carl made a good point. It depends on what you're going to do. It really shouldn't go from battery to ground. It should can go from your controller bus to ground, and you should size it for about 1 milliamp.
Okay.
So let's say you have a step down regulator that's stepping 12 volts down to 5 volts. Then it should be a 5 milliamp. Excuse me, a 5 k ohm resistor.
Okay.
Okay, and just be on between the 5-volt rail and ground. And all it's doing is adding a constant 1 milliamp drain. So when you turn everything off, it's still will be a 1 milliamp drain, and it should speed up the decay a little bit.
Okay.
You can get, I mean, it's an idea. It's something you could try.
All right. Thank you.
Yeah, you need to switch it on and off that quickly. I mean,
Well, it does take a while until it seems to work again. So
How long does it take you for the LEDs to go off?
20, 30 seconds maybe? For the motor shield LEDs?
You mean the LEDs? Your LEDs on your motor shield are staying lit for 30 seconds?
Yeah, it's the standard club motor shield. I just thought that was standard.
Well, here
Does seem like
your switch circuit is you got to sketch out the schematics so we can see what you got hooked up to what, because
All right. Yeah.
there's something funny going on there.
Yeah, they shouldn't stay on for 30 seconds.
Yeah.
Okay.
At that point, I just dunk it in a bucket of water, really. Just
Yeah.
what?
Salt water, preferably.
Yeah.
Yeah. So I think you might not be turning off all your voltage supplies, is what I'm suspecting.
Okay.
Yeah, Carl's right. You probably need to go look at your power wiring and see what's going on, because usually the LEDs are really just a load dropping resistor and LED, and the LED has if it's a red LED, it's going to be 1.22 volts or 1.4 volts. So, you know, they size the dropping resistor to give you whatever it is, 5, 10, or 20 milliamps through the LED at bus voltage. And if it's staying on 30 seconds, that's telling you that that bus is still high that long. It's dropping probably. It's probably getting dimmer, but yeah, you got something wrong with your power wiring.
Okay.
All right. I'll sketch
Very
out a
good.
schematic next time.
Yeah, sketch it out. Let us, and then it's easier to talk to schematics. So,
yeah.
I think we still have 2 or 3 more, at least. I think, Chris, did you have your hand raised at some point?
I want to see
Yes,
what
I
the
did.
room is going to do.
Just 5 minutes, maybe. The topic itself is probably worthy of a longer discussion, but we were talking about simulation earlier, and I've mentioned, you know, that I'm maybe 2 weeks ago, I've mentioned 3 weeks ago, I'm a big fan of Opalia Sim, and so I just since you guys are doing this line following, I just thought I'll show something real quick here. Hit that present button. Screen, which one? This one. Are you guys able to see my screen?
That's great.
Okay. So I didn't create this one, but I was just poking around in the examples that come with Copelia Sim or VREP as it used to be called, and they do come with one line, you know, tracing sort of demo. And I just again wanted to spend just a few minutes kind of showing this and promoting this, since I'm a real big fan of it, and especially the simplicity of this simulation environment compared to other off-the-shelf ones that are out there. And I'm just going to hit the start button little quick before I zoom out here. And again, if there's interest, I can do a deeper dive on this at some point. But I really just wanted to show you guys what this thing is capable of in a real nutshell. And someone was asking about vision sensors. I think it was Jan. And so this is an environment where you have actually a number of different sensors that are built into it. In fact, the way they are doing the line sensors here, they're actually modeled as vision sensors or as tiny little cameras, and then you just kind of extract the information from it that you think you need. If you really just want a little, you know, line sensor, you start with something more sophisticated, but then you treat it more as a very, very, very simple sensor. So this is, again, what's really nice about it is it's easy to use. You can see on the left side here, this thing I clicked on right now called Line Tracer, that represents the robot. Everything else is kind of the environment. And you can see the robots put together, you know, from various primitives here. And again, the sensors are kind of where it gets interesting, right? So you can see here, like I said, in this particular case, it's modeled as a vision sensor, and it's got certain properties you can configure. And you know, the other fundamental sensor type they have is a proximity sensor, and again, there's a lot of things you can configure about it. And then and then sort of extract the information you need. The joint, becomes the motor basically, and to it is attached a wheel. Now you can get pretty fancy with the visualization of this if you want to and have the time, or and whoever created this demo, right, put in a little bit of effort to make this look like the real robot. But you don't have to do that, right? You can, you don't have to spend time on that. That's what it sort of looks like at first glance. Oh my God, this is going to take forever to put together, right? But the point is, all of this visual aspect is really just icing on the cake, right? All you really need for simulation are very primitive shapes. You usually want to stick to circles and rectangles because they are fast in simulation. Everything else is more like just a skin, right, on the actual simulated sort of object. And so don't get confused by the sort of nice looking thing. Or they have some other examples where they could get even more fancy with the appearance of the robot. But so it's out of a couple primitives here, which are again primitive shapes, and then sensors and what they call the joint. You put together a robot, and then you have a number of ways of programming it. In this example, I mean, the way they're doing it, which is I'm not a particular fan of, but I just want to show that they happen to be using Lua right inside the environment. Again, that's kind of their quick prototyping way of doing this. And once you strip away all the boilerplate code, you can see here, this is the actual logic, right? So if we see something on one side, well, we're going to slow down on that wheel. If we see the line on the other side, we're going to slow the other wheel down. It's kind of their very basic logic that's at the core of this particular script. And there's obviously some boilerplate code around it to get the data in and out. So that I'm not a fan of, right? I think where it gets real interesting, and again, Gian, I don't know if you're still there. You were kind of, the keyword you mentioned is, along the lines of running the same code on the robot as in simulation, and that's very much possible. I think I kind of briefly mentioned that the other day, and again, they have different ways of interfacing with the simulation engine. You don't have to use this Lua method of doing it. They have a C API that I think works very well for setting something up where you have code that can run on a real robot or in the simulation. So in my again, I've used it successfully for the Trinity robot firefighting robot competition and helping me debug my code. So this is what I put together for that. You can see the Trinity arena. Most of you, or some of you, might be familiar with that. And then you can see sort of my my simulated robot there with a couple IR sensors here, proximity, and those are the sharp IR sensors. I have down-facing line sensors, modeled as cameras. Then I have a couple sonar sensors. I have a pan tilt servo for fire extinguishing. I have flame sensors that again modeled as sort of cameras in here. So again, actually very simple to put together in here. Again, two joints here for the motors, some wheel attached to it that matches sort of the size of my real wheel. Obviously the base matches the size of my real base. I did not pay attention to inertias and mass and torque on the motors, because even without that, it was good enough for my purposes. I have servo motors on my real robot that are a pan tilt, head for fire extinguisher. So again, you see additional points here that represent this sort of, again, it's not sort of rendered visually here, but it represents sort of a pan tilt setup there, to which I've attached both the flame sensors as well as the the fire extinguishing mechanism. And so again, where it gets real interesting to me is when you sort of use their API that you can use from a C program, and now you let your robot control logic, drive or interact with the simulation. So again, without sort of going into the total deep dive here, just real quickly, if I hit the start button here, with obviously a little bit of boiler code that needs to be around it. And I don't know if this wants to start or not. Oh, okay, here, there's my command prompt. Sorry. All right, so it came up. This is running some basically my code in a visual, sort of in a Windows command prompt. It's the same code that runs in the real robot plus some boilerplate, wrappers around it. But if I hit S here, which is kind of simulating a start signal, then you can see this starts to sort of actually move, although a little slowly. This laptop isn't particularly fast. But again, the real point of this is, for me at least, I could now go back into the Visual Studio here, and I'm not running it in the debugger here, but I could actually, if I ran this into the debugger, I could actually, hit the breakpoint potentially, or I could hit the pause button in Visual Studio, and everything would pause, right? So my code and the simulator are running in lockstep. That's kind of the key here. They're not sort of talking to each other in some asynchronous fashion. It's specifically set up in a synchronous fashion, completely lockstep. It's my robot's code, through some wrappers, is driving the simulation. And if you were to look at my main loop, again, this is the real code on the real robot, but if I run it on Windows, certain code is disabled. Like, I don't have to do any low-level data acquisition. That would only happen on the real robot. Instead, what I do on Windows, I call into a function that obtains all the sensor values from the simulator. Okay? And then I proceed with the regular robot's logic. And when I'm done with all the logic, I'm just going to send all my outputs that I computed to the simulator. And then I'm going to tell the simulator, right, now do another simulation step, right? So everything is happening in lockstep. And if you hit a breakpoint somewhere, or you hit the pause button in Visual Studio, you can now examine, okay, why did I just bang into the wall or something, right? Where exactly am I in my logic? Where is the robot, in the simulated world? What exactly are the sensor readings, right? You can hit the pause button basically on your robot, and you can that way sort of debug your logic in a way that I feel is a lot more productive than on the real robot. And I've been finding this very, very, very useful.
Hey, Chris,
I don't use more time on this today, but I certainly can do a deeper dive if there's interest, at some other time.
Chris, I just have two questions. One of them is, can this simulate a Python-based robot?
I believe so. They keep adding more and more ways to interface with it. They really don't care how you talk to the simulator. Since the API, I'm using the C-based API, which by definition means you can interface with that from Python, right?
And then the second question is that I'm looking at their website, and they've got a free player and an education, which I can't qualify for, and a pro version. I'm assuming you need the pro version to do this, or?
Well, I think, I believe I qualify for the educational version. I'm not making money with this, so I didn't read all the fine print, but let's just say that's what I'm using.
Oh, okay, because I was just wondering how much it costs, because I can't get the education version, and you need editing capabilities, which looks like it comes with a pro version, and this Swiss company doesn't list the price online, so I don't know how much it costs.
Yeah, they used to have an open source version too, basically unsupported, but basically the same thing. I don't know if they still have that. They merged with some other company at some point, But again, if you look at the fine print of the educational version, I don't know. I mean, I think hobbyists qualify for that. I don't think, you know, they want to make hobbyists pay for this. They want to make people pay for this who are trying to simulate factory environments and whatnot.
Oh, okay. All right. Thanks. Yeah, it's interesting.
Hey, thanks a ton, Chris. I think if you'd be up for it, we are always looking for monthly presentations to DPRG. So if you'd be willing to do a deep dive, I bet people would raise their hands if they're interested. But I know I'd love to see a kind of a good, yeah, you've got good support here. So
all right,
can we call you back by popular demand?
Let me see if I, you know, can put some material together. I'll get back to you if I can get the stuff together for that.
Hey Chris,
Yeah,
can you put a link in the chat on where to find the software?
I'll do that. I've got it right in front of me. I'll do it.
Hey, Chris, Jen here. So I like this. The main interest is I can use the same code that I intend to run on the robot in this environment. That's perfect. And debugging, perfect.
You can. I mean, there are a couple, you know, you have to do things a certain way. There are sort of a couple of, you know, caveats to that, but technically it is possible, right? If you do things the right way, and if you you know, take a few things into consideration.
Yeah, if there's some way lower the entry to try it, like I mean the simulation existing is, the beauty of it is I just download and it runs. So
yeah, and I was actually thinking of putting a little Hello World together where it's all set up but without too much going on to illustrate that. So that's what I'll have to do. I would use that also for a deeper dive, just so that you know, it's not so overwhelming with too many sensors going on at the same time. So if I find the time, I'll do that, and you know, that could be then something useful for people to look at, you know, without getting overwhelmed right away.
Yeah.
I should point out too, though, you know, with Ron Grant's simulator, there's no reason why you can't just, since it's in C, if your robot's in C, you should be able to just pick well, it's in Java, so there are differences, but basically it looks like C. You can pick that code and you could put it in your real robot too. I think the real challenge between simulation and real life is the degradation that you see in real life of your sensors because of the light sources.
Yeah,
that's where the real, but there's no question the value of a simulator.
Okay. Yeah, so sensor noise, you can, in this particular environment, they give you basically a clean signal. They give you accurate. If you're modeling a distance sensor, they give you the exact distance. So if you want a crappy sensor, it's up to you to add some noise to it.
Right, exactly, and you can do that with Ron's too if you wanted to. But I'd say like first get it working on a perfect world, and then
right,
you know, and then see what you can do. Because for like the challenge course, it's not, you know, it's hard enough that if you can get it to work in the perfect world, that you'd be a way leg up on the next level.
I think for something like line following, where you're trying to be extremely fast, the bigger challenge would be making the whole dynamics of the robot match the real world, right? Because that's where inertia comes in, the torque of the motors, the mass of your robot is gonna matter a big deal, and so matching that in simulation, that can get tricky, right? And if you don't match it, well, then your real robot's not gonna turn exactly the same way as the simulated robots. I think that's where more the challenge is, especially for line following, rather than the sensors. The sensors, you can, I think, again, you can do things to make them noisy, but the dynamic behavior is a little tougher to match, I think.
Mm-hmm.
Okay, guys, we have maybe a half an hour left, and I think I'm pretty sure Donna had something, and Kareem, did you have something as well?
Yeah, Kareem's got something. He's been showing it.
Yeah, I got something.
Was there, aside from Donna and Kareem, I'm going to pass on mine tonight for personal things, but was there anyone else did anyone else have something else to show? So let's go Kareem and then Donna, and then I think that'll lead as a segue into the contest discussion and the group to group thing. So Kareem, if you could just, I don't know, 5 or 7 minutes.
Hopefully less. So
okay.
So I'm not gonna present. If you want to see this in more detail, just pin my webcam. And I showed this robot. This is my outdoor path following robot. I showed it like 2 weeks ago, sitting down there at the beach, and got another little success fail update. So I don't think I'm going to show that video again. For reference, this is Dallas, and this is like a calibration square in my yard. I don't actually have video of it following the square, but it now follows it pretty reliably, and it's like an endless square, so it'll just keep going around and around and around until it runs the battery out. Also, I think I told you about, so the team number is 6832. So I was looking for a place to sort of trace this out on the dirt. Didn't get it done at the beach. So I found a baseball diamond or softball field pretty close to the house. So this is it. And you can see that the path is traced out here. So the team coded this path explicitly, basically. So if you just go into the details and you look at the properties, you'll see that the individual points show up. And if you export that as a KML file, you'll get all of the GPS coordinates of it. And the idea was that this thing would start at the back and then trace the 2 backwards, and then go up and do the bottom of the 3, and then this one. And this was where the fail came in, because once it hit this end point on the 2, it was supposed to start backtracking its points until it hit this point right here, and then switch over to the next character. Well, it just kind of stalled right here. So I don't know exactly why. This happened about 30 minutes before this evening session started. And we were running away from the storm. The field here was already completely sodden. So let me scroll out a little bit. And then I managed to download a video of the drone. So Tycho was filming it as it was trying to do that too, right? So I'm going to go ahead and play this. Is that coming through okay?
Oh, yeah.
All right. There might be some background sound of dads yelling at their sons playing soccer.
So when you're lost on a deserted island, Kareem, your robot can say, "Rescue us."
That's right. That's right. I was going to do a big SOS.
What about it too? That thing is really hard to pilot, to follow that robot. Go up higher.
Yeah, the professor in Gilligan's Island would be very jealous.
It's very weird too.
Oh, maybe that was the start. This was just getting to start.
Yeah, that looks like it too.
So we think it actually did the 2 and then basically died. And I have no idea why it died. Again, this field is a dirt baseball, softball field, but it was completely soaked already before the rain. And so it was like getting really, really mushy right here when I went to retrieve it. So we're not exactly sure, I think I have another shot real quick of it higher up. So I don't know if you can still see it, but he's going up so that you can see the whole thing. The track is along here. There's the robot. So it looked like the 2 that we were trying to do. And so we just need to get it to sort of finish that entire path. That's all I had as far as the update goes.
Cool. Cool. Really cool.
So having fun with it.
So of course it's the youngest team in the whole group that's showing everyone else off right now, but that's cool. I think they have a ringer at the helm.
Huh?
Okay.
Well, I definitely helped a lot with this particular one. I didn't do the
That's what I mean.
Yeah.
Okay.
They're not going to claim this as their unique project.
Entirely.
Basically, I'm sort of letting them in on it as a sort of just a mentor experience.
Very nice. All right. So thank you very much. That's so cool. Hey, Donna. So we were trading emails or something. And I can't remember now. Was this something on your personal side to share, or did you want to just jump right into club to club stuff?
Oh, well, actually, no, I didn't have anything specific to share tonight.
Okay.
But yes, I'm interested in what your club's plans are, especially for November, for any virtual contest kind of planning, or I am very interested in hearing about that. Yeah.
Okay, cool. So so for those that aren't don't know on this call, so Donna's from the Seattle Robotics Society, if I've got it right.
Mm-hmm.
And so that means we have Massachusetts, LA, Washington, and New Zealand, and Dallas. So we have all those places represented on the call by my count. Not bad. So I had sent a mail to Donna asking also about presentations, because we're always looking for monthly presentations. And I had made an offer for anyone that's on the call that might want to jump in, but I'd made an offer that maybe some of us from the DPRG could present to the Seattle Robotics Society, if in turn perhaps we could get someone from Seattle Robotics Society to present to Dallas Personal Robotics Group.
Yeah, yeah.
And that way we could help get some fresh content.
Yes.
A little easier.
Right. I think that's a great idea. Yeah. Sorry,
Okay.
I have not seen your email yet, Carl. So.
Oh, okay. I sent it to you at the SRS. Anyhow, Don, I'll put my email in the chat here again, and maybe we just go directly in.
Okay.
Not
And
through the
I'll go
group
ahead
email.
and I'll go ahead and provide my direct email as well.
Okay.
I can jump in here. I've actually done a couple of presentations for SRS in years gone by. And Donna, I'm David Anderson. We've actually communicated. It's been quite a while. I got one of these. 2000.
Okay, great.
It seems to me like a couple of years ago, I shot a video of my outdoor robot finding cones in the front yard, and I posted it on the SRS list. And your reply was, where were you during the contest?
Okay.
Excellent.
Oh, okay.
So, okay, so let me try and open this discussion, and then if people have to peel off, that's great. But in the interest of time, let's see how far we can get in the 15, 20 minutes. And I think what we discovered last week was that both clubs try and do contests each year, at least one, maybe two contests each year. And we discovered that in this time of COVID, it's kind of difficult to meet in person. So out of the discussion brainstorming last week came this idea of a kind of a virtual contest where we would use a simulator. And the proposal was to use a framework written by our DPRG's very own Ron Grant, and it's written in processing. And the idea would be that we'd have kind of simple contests, maybe a couple of line following courses, at least one. And then contestants could download processing, download the standard course. They could write their own robot controller and get it working in their own home laptop, all this for free. And then at or near competition day, they could email the robot in, right? So no physical robots were harmed in this process. And a contest coordinator, and I think Doug was showing some things he added to Ron's simulator, but a contest coordinator would then on game day load each individual controller into the environment and run it around, and then we could all participate to this contest online. And there was a lot of pretty positive support for it last week. So my hope was, and Doug is DPRG's traditional rule maker, evil rule maker. So I think Doug was going to go and look at like how might we do this in practice following typical DPRG methods. So my hope tonight was that we could talk briefly about, Doug, what you've seen and pulled together planning wise, and then if we're all agreed, I was going to say let's just quorum on call here. Let's just decide to go for it. We'll call a contest in November, and we could use Tuesday nights and maybe even the Saturday meeting, one or two of the Saturday meetings, to get people and help guide people towards this. So with that in mind, that's what I was thinking. And let me ask Donna before we get Doug to jump in. Donna, that was my perception of it. Could you share whatever you thought from the Seattle Club point of view?
Well, first off, sorry guys, I seem to have some background static going on for my voice. But we as the Robothon committee still have to meet within the next week and a half. I'll be presenting some ideas that I gleaned from our meeting last week for how to move forward on the SRS side. But I like the idea about the line following simulator, and perhaps the Seattle Robotics could borrow that open source code and be able to use it freely as well for that type of contest. But perhaps we would want to, being that we have also a good set of existing rules and popular sets of contests, we may also want to, I'm going to be proposing to the committee that we also, for the idea about a cheapness of a robot course build for those who have the robot already in works, that we may want to move forward with the SRS Robo Magellan contest. Run that in a virtual, like what we talked about last week, where each person in their own cave, so to speak, does their own build in solo or a small group, but probably solo. And then they build their course to the virtual rule specifications, and then they run their robot, videotape it, and then upload that video file for the official entry during that 3-day window that we talked about last week for actually submitting their contest entry. And so that's kind of the way that I'm going to be presenting these virtual contests to the SRS Robothon committee moving forward. So either the simulator or Robo Magellan, also line following might be the actual physical robot line following might be another alternative. And then we also, like what you guys have had in the past, we at one point in our Robothon history, we also had a freestyle or open robot concept as well. And so I think that in this virtual environment for our first run on the SRS side for virtual contest, the idea about the open or freestyle robot contest might be a good option for us as well. So more than likely, the way just knowing the guys that are with me in the committee, more than likely we'll probably go for the open or freestyle robot entries. And that way, depending on what the robot builder has in their shop at present, or what's easily accessible for building a course, then they can go ahead and they can do that. Or if they just want to have a show and tell fun robot, they can showcase that as well. The whole idea is to get people to do something robotics wise, as far as actually building something, and then videotaping that and then uploading that into for the panel of judges. So that's kind of what I'm thinking of at this point, but nothing is official at this point.
That's cool. How many people do you think, Donna, are in your club? How many participants do you think you'd have?
Well, that's part of the problem, Carl. Over the last, probably 5 years or more, a lot of that's one of the reasons I'm so enthused to be joining in virtually with your club, is because you guys actually get in there, you build robots, you've got the enthusiasm like I do, and a few of us over on the SRS, to actually utilize the technology to build things and get creative this way. But sadly, most of the people that attended before COVID attended our regular meetings. It's gotten to be more of a just kind of a social gathering kind of club, and sitting around and watching technology type YouTube videos, that kind of thing. So sadly, that's kind of the way that the club has kind of been going. So even before COVID, for the last several seasons of Robothon, we have had very few actual club members that actually build robots to actually bring them to the live contest. Most of our contest entries are from people in other parts of the nation. And so I'm really not quite sure how that's going to work out as far as, but it'll be a fun experiment, I think. And that's what I'll propose to the committee for us to try this anyway, regardless of how great of number of entries that we get. I really don't know, Carl, how the number of anticipated robot builders that will actually come out. But yet then again, if we are promoting within the club this freestyle or open style contest type, we might get a lot more enthusiasm being built and actually get people to to get off the shelf actually and build something that they can show in an open type format that doesn't necessarily conform to a specific contest, because we've had a lot of problems in the past of a lot of the people frankly not liking the contests that we've got available at any one time. And so this might, I'm hoping that this kind of idea might get people off the fence and actually do something with it.
Okay, cool. So, yeah, and that way you can, and I think we see the same thing, that you might be able to find participants even no matter where they are.
Yeah.
And still, and I think what we've seen too is that when you get it only takes one or two people who just go crazy or gung ho on something, and somehow there's this halo effect that drags other people in. So
right, yep. So
okay, so so it also seems that whatever your time frame for SRS would be, I think we're still probably for DPRG talking about November, so kind of a short fuse. But I think we'd surely be open for anyone to participate. We always are anyhow. So
okay, well, that's part of what I'll talk with the rest of the committee about, Carl, is the idea that even if we sideline this year for October, because that's when Robothon was supposed to actually happen, was early October.
Yeah.
And so if nothing else, I'm going to be suggesting that we join in virtually with your November contest. So that's the other thing I'll be mentioning.
Oh, that's awesome then.
Okay.
I followed the SRS list for 20 years, and but then it went away.
Yeah.
And so where is it? And I don't have a Facebook.
Okay. Well, let's see. So let me look here in my notebook. I just happen to have that notebook right in front of me. What happened, being that the Yahoo groups, in the Yahoo groups environment, as I'm sure a lot of you know on this call know, radically changed as far as their rules and posting limitations, all that regarding emails. And so it was that kind of environment that we used to have. So with those changes, we ended up switching to groups.io. That's the environment that we went to. And if I can find the specific email address in here for what we have changed to, I will share that in the chat, because that's the email email hub now that has replaced seattlerobotics@yahoogroups.com. That was our old email environment. Okay.
Hey, Donna.
Uh-huh.
I think if you could turn your headphones volume down just a hair, you'll get rid of some noise.
Yeah, I see. Donna, I just put the link to the SRS home web page in our chat.
Right.
I saw mention of groups.io in there, but it was the raw domain, not the SRS fraction of it. So if you could put that in there.
I will here.
Good.
It's the list server I was looking for.
Right, and that's what I'm. Yeah, that's what I'm. Well, okay. So are you talking about the IRC chat, or are you talking about the email list exchange?
The second.
All right. So it is what I said before. Still stands true as far as switch to groups.io. And shoot. Oh, it's over here. That's where it's at. Okay. All right. I found the correct notebook now.
Do you know how to post on our list server, on the DPRG list server?
No, we should probably chat offline. I think David had a good point of if you're not already on the DPRG email list, we can get you there. But while you're looking and we're pondering those things, I was wondering at this point, Doug, could you take a few minutes and let's take 3 or 4 minutes, 5 minutes? Oh, perfect, Donna. There's the link to groups.io.
Okay, so that's the main platform location of where all the emails are stored, but then there's the respective email address that you can send and receive emails on. And if you go over to that URL, you'll be able to see it, I believe.
It looks like it's called group email addresses. And you can subscribe and unsubscribe just right there from the group email. That's cool.
Right, right.
Okay.
Okay.
Thank you.
Uh-huh.
So Doug, with that kind of a segue, knowing that we might be pulling in some extra participants from around the country, at least up in Washington, what have you been thinking about? You were showing us earlier the changes you started to make to Ron's simulator. So I presume we're still thinking that simulator would be the framework.
Okay,
And then
there was basically 4 ideas thrown forward.
Okay.
Okay. One was the freestyle. Okay. And I've got some thoughts on that, but I haven't really tried to work a rule list because I was keyed on the simulator this week. The second, so one is the open style, and basically the way I see that happening is anybody who has a robot that has some function could show it as either a technology-based robot, otherwise something that uses advanced robot, maybe it uses advanced technology.
Sensors, actuators, mechanics,
whatever,
whatever, algorithms.
Yeah, and then the second category would be one that had function, the one that had the most interesting, unique function. So like maybe I'm just throwing, I know this has been done 1,000 times, but I'm throwing it out as an idea. So a guy makes a bar robot. Okay. So that would be his function. His function is a bar robot. Or like Chris was talking, it was a firefighting robot. Whatever the function is. So it would be one that would ideally be unique functions. It might be a home automation function. It's truly an open category. And then the third one would be fun robots, okay, which would be ideally not political, but they would truly be fun, something fun about them. You know,
25.
like John makes a lot of fun robots.
Yeah.
You know what I mean? So it'd be something like that. So anyway, those would be the three categories that your robot you could select which one you wanted to be judged by. And it would be curated, and it would be judged by a committee. So that's really subjective. Okay.
Greg, you're saying that we send a video of the robot doing something, and that's what it's going to
exactly. And
that opens so many possibilities. I mean, if I can send a video, I've got robots that can levitate and travel through time.
Well, I hear you, Dave, but
all that's needed is a video.
Well, I'm just saying is, but it's curated, and so like if you suddenly have a robot and we look at it and there's no wires on it, yet it's levitating through time, we probably would say maybe that's fake. You know what I'm saying? But you know what I'm trying to say. So these are ideas, David. We know we're just throwing out ideas. The second idea was an actual. We would do Robo Columbus. Okay, it would actually, since that's usually not a real high robot count, and it could be done outdoors. We'd really just do it. The next one was that we would use a course based. So like say 6 cans. It would be actually done at the makerspace, but it would be done so there was no more than 3 participants at a time. Okay, so people would come in. They'd have these were ideas that were thrown out last week. So the person would come in. He would have, it's 1:15. He would come in. He'd run his robot. The judges would look at him, get his time and everything, and then later the results would be published with video. Okay, that was the third idea. And then the fourth idea was that we would use Ron Grant's simulator and actually run a simulated line following. All right, now that's the one I spent most of my time on this week. So the other ideas haven't been lost. I just haven't had a chance to get to them. And these are all proposals, remember? So what I'm going to show now is a link, and you guys can pull it up. Let me get on chat here, and let me put the link down. I actually have it somewhere. Oh crap, come on. I'll copy now. Where is that? All right. Okay, it should be there. You guys can go to it now. And I should be able to go to it. And okay, and I'm going to share my screen. So you don't have to go to it. You can just look on your screen.
Oh, I see what you did. Okay.
Okay, what did I do with it?
So you pushed the code plus your changes to the DPRG GitHub, which has all the contests listed.
Yeah.
Okay.
And if I can, okay. What the world? Wait a minute. I'm having a little bit of trouble, guys. I don't know. I just had it here a second ago and it went away. Okay. Can you see it now?
Yeah.
You should see something that says line following.
Yeah.
Right,
You got some rules.
let's just read through it together here.
Okay.
It's only 2 pages. So So the objective is, the competition objective is for the user-supplied robot models to compete against each other by successfully completing one route around a virtual line following course. We're going to use a specifically modified line following simulator that was authored by Ron Grant. And what the competitors will provide is the robot controller and initialization files. Okay, a judge inserts the file into the simulator and runs the robot. Okay, the competition, it will be live streamed at a date and time published by DPRG's website and meetup page. All right, the next thing, robot there. The robot consists of 2 files basically, and they have a naming convention. All right, there's an example there, and there's a skeleton version that will be included in the download. Okay, the types of sensors that are being allowed. Now, this is what I'm proposing. If you guys want to do an array sensor, you know, like a video sensor, we could probably work something out, because really all that is a big spot sensor. Okay, well, no, I shouldn't say that. It's a big array sensor. But right now, the simulator has 2 types. A spot sensor is a rectangular array of pixels, and they have a maximum size. We're setting the maximum. This is not a simulator limitation. It's a rule limitation. We're setting them to a maximum of 225 pixels per spot. Realistically, I don't think you want one that big, but Ron and Will have used some that size. It doesn't have to be square, but how the value is calculated is that if you had 225 pixels, if 113 of them were black, that would be over half, and the sensor would be considered black. If it was 100 pixels that were black, it would be less than half the pixels, so it would be white. Okay. Now that's why in my own particular case, I use 25 pixels. So that would mean that 13 pixels would have to be black for it to be considered black.
Why not a gradient sensor?
Huh?
Why not a gradient? Like if it was 50% covered, then it would be a 50-50 grayscale.
Well, the actual value, the intensity, it is a grayscale.
Oh, okay.
Okay. So
it's the average intensity.
Yes,
The entire.
But the way the sensor is done is that if half of it is considered black, it would go black. Okay, I'm pretty sure that's the way it is. Now, a line sensor is a linear array of cells that are adjacent with no space between them or overlap. And each cell is either wider. Again, each cell, in this case, it is 25 pixels per cell. So if 13 cells in there were black, or the gradient or the density of the cells showed it up to be black, it would go black. Okay. But what you have is a whole line of sensors, and they're smaller. And I think this is, you can have up to 4 of those right now. Again, that is not a limitation of the simulator. That's a limitation that I put on the rules because I want you to be able to see the sensor results on the screen. Okay. And if you have more than 4, you start covering up the screen, because right now there is no way for the sensor to show its state. All right. Now that's something I've got on my to-do list, but right now it doesn't exist. All right. Okay. So the next one is the simulator. That points to the specific one that's in this directory. All right. And it says additional instructions are available at the link above. Well, that's a to be done. it hasn't been. My intent is to actually go over every variable that's likely to be used and show so a person can show how to do it. All right. Okay. And there's also a link here to the original one if you wanted to use Ron's. I think personally my own, I won't go back to Ron's. I'll be using my own. But it's Ron's simulator. All I've done is tried to make it a little bit easier to use. Okay, so every robot would be given a chance to run. And if the robot fails to move, the guy actually has a chance to go back to the end of the round and run. This is a standard DPRG procedure. I don't know how important this would be because the time you would have to send a new file in might be pretty quick. But you could do, in theory, what could happen is your robot didn't work, it didn't move. You would have until the end of the round a chance to resubmit another file and correct the problem. All right. There are time limits. There's a limit of 5 minutes to the beginning and advanced. 6. Okay, that's an error. I removed the sub-channel level. I originally had 4. I've gotten rid of that. So I see a typo. I'll have to remove that. And then the run line for the challenge course is 15 minutes. Now, obviously, if somebody at 15 minutes is still on the course and running, we're going to let them roll. But I'm just saying that probably for my experience, from what I've seen, I imagine by 15 minutes you've long lost the course. All right, now a round allows each competing robot, and it consists of only 2 rounds, so you only have 2 chances at this. Okay, and the reason for that is because of time. All right, this could get to be a really long thing. Now, maybe that's something we want to go to the traditional 3 rounds. I don't know. Okay, so the play, this is how it's done. So you would submit 2 files. They would be loaded into the simulator. The judge would place the robot on the course. In actuality, if you look at the simulator, a point has already been selected. I don't really think anybody's going to want to change it. So your robot would go to there, and the robot would complete one lap of the course. Now you say, well, Doug, traditionally we've done 2 laps. Yeah, that's true, and that does help to prove robustness. But I'm going to tell you what, guys, after watching one of these robots go a simulated wrap, I'm pretty well ready to hang it up. My eyeballs are rolled back in my head and everything. And that's one concern that I have, is that unless people figure out ways to make the run fast, this could be really long. So I took out I originally had 4 levels here: beginner, advanced, and sub-challenge, and then challenge. And then I said to myself, to hell with it. We'll get rid of the sub and we'll just do beginner, advanced, and challenge. If you use the example, you should be able to do the beginning and the advanced. So the real challenge for you there with the simulator is how can you do it fast? Okay? Because the algorithm that's in the example will do both those levels. Okay? So that's something to think about. Here's the scoring. A robot score is by the number of quarter lap segments that the robot travels within the time limit. Okay, so this is where the time limit could become important. So a perfect score is 4. That means you did your lap. Okay? No prizes or place for prizes will be rewarded to a robot that at least doesn't do a quarter of a lap. All right. And then there's an example of scoring there. So you have 2 successful that completed a full lap with a time of 90 and 280 seconds. The next one goes a half a lap before running out of time. However, is still on course. And the last robot goes off the course at 0.75. So the ranking would be, the first place goes to the 90-second robot, 90-second time robot. The second place goes to the 280-second time. The third robot goes to the robot that traveled 0.75 laps within the time limit. So that's the basic rules, okay? Like I say, you can use the example algorithm and do the first two levels, but the question is how fast you could go. You can go fast enough to meet the current time limits. So you could run just the example in those 2 levels and make these times. Now, there's 2 ways to correct that problem. One is to cut down the time limits so that you got to do something to speed those suckers up, or whatever. Now, the challenge course, that's where the real meat is. I know that none of the examples, neither Ron's nor Will's or the example, will make the challenge course. Now, I will say this, Will's does a pretty decent job of getting part way around. So, you know, that would be the place you would look for ideas to start your challenge course robot. But Will's is a weird tricycle thing, but his algorithms could still be adapted to a differential. You might be able to, the other thing you have control over is sensor placement, and really smart sensor placement could really make a difference on speed and the ability to do the advanced the challenge course. So there is still quite a bit of challenge out there, but that's it. That's what I've got to show at this point. All right. It looks like I've already, so
cool. Thanks, Doug. That's a lot of work. And it seems to me that there's a few key things that caught my attention. The first is that there's an implicit robot API defined, because all robots submitted consist of 2 files. And within those files, I mean, we don't want to change the interface to the simulator, right? So the whatever those interfaces.
No. Okay. Do you want me to go over those parts of the? I can show you those 2 files if you want to look at them.
Well, I was just skimming through them, but maybe I'm making assumptions that aren't correct. But
okay, so the robot representation, like, you know, in the case where Chris showed another simulator where it had a really elaborate, well, you're limited to 2D, but there's no reason why you couldn't create a very realistic looking robot in the routine called user draw.
Yes.
Okay, so user draw is where you draw your robot.
Right.
Now the realistic, you know, in my case, in the example one, you see there's 2 wheels and a center marker, and that's all you have.
Right.
You really, in my opinion, you don't really need much more than that. You know, Ron runs it with with that routine completely empty. Otherwise, all he shows is the X and Y axes. Now, the next part, which help me out, Carl, you're looking at it. What is the second routine called?
Well, there's the controller user robot.
Yeah, okay. Controller user robot is where the algorithms go. All right. Now, in the example, if you look at it, if I remember right, it just has a centroid model. If you slide,
Yeah. That's.
And that's the whole meat. That's what calculates your value. Now, if you also look in there, there's a PD controller.
Right.
Okay, and he doesn't go into great, he does. So if you look at it, it just says PD controller, and you can look at it, and you can, if you know a PD controller, you can see that you can realize the proportional component and the differential component. Okay. I don't think, I can't remember. Are the sensors aren't touched there? Are they? Are they discussed in that file?
I'm not seeing the details yet. My only point was that by virtue of the fact that of how these files are constructed, that in effect defines the API. So there's a lot of flexibility or not with what you can do.
There, you can put in any algorithm you want in there. Okay.
Yeah.
I mean, you can actually, if you wanted to do like, well, if I see this on my sensors, I go to here. You could be a big state machine.
It's just going to get ugly because it's a single file. But
yeah, you could do it. All right. Now, if you switch over to the, in fact, I got to do this because I can't think. Give me a second.
You got a topic here. You do.
Okay, here it is. Okay, so if you look at the example user in file. Oh, wait a minute. Hang it. Let me open this up.
User init.pde. So yeah.
Yeah.
So Doug, what I was trying to get at is that, I mean, it's always fun to catch up to speed on somebody else's code.
Yeah.
And if we're going to be trying to coerce a bunch of people to compete, and then I think it could be worth a full-on session to go through it and to help people get started.
Yeah. Yeah, we could do that. And like I say, if you look at this, so if you look at the user in file, basically it has some globals and some switches. All right. And then the next thing that you do is you select, you have to declare your sensors. So
you're here.
And you can't, the line sensor one, you have to have it even if you don't use it. Then the user in, you can see all the different courses that have been loaded into the data directory. So all of the challenge course test courses that I had developed before, the 0, 1, 2, and 3, they're in there. All you have to do is uncomment the right course, and you can play with it in the simulator. Then you have the novice fall, line following fall 2018. That's the beginner course. And the advanced course is the advanced course fall, and that's the one that's uncommented. Okay. So all those courses are available to you as for test courses. Then in the next portion down, you actually configure your spot sensors. Now I did it in an array. If you look at Will's example, each one of those is individually written out. He calls them like spot front center, spot right center, he has names for them all. And that all works too. There's nothing wrong with it. The line sensors that are commented out, they don't have to be there. It's just sometimes I add a line sensor real quick just to show what it can do. All right. Now below that, those stub functions, you don't want to remove them, but those are, if you want to use robot steering angle and robot wheel velocity as opposed to speed and heading, those would be what you would set the key remap Boolean true up here, and at the top, you would set it to true, and then you would modify that to your heart's intent. The one that exists there is the one that will set. But really what that does is give you access to the class functions, steering angle, and wheel velocity. Okay? And then the alternate drive update, or the normal drive update, uses speed and heading. And this is, you need this to be able to change it to wheel velocity and turn rate. Otherwise, you have speed. There's the speed variable and a turn rate variable, and how you define what those do. For a differential robot, you don't have to use this. Okay, does that make sense? So it's pretty simple to set up a robot. It really is. And the cool thing is you get to play with all the sensors in the world, even though realistically, you might come up with a configuration that would be pretty hard to mechanically regenerate. But as you can see in the user controller, you could make code that's exactly importable to into your robot, and it would work. So I don't know if any of that helps anybody, but I just wanted to show that. So these are the ideas. This is the code. If you got any ideas, instead of using this time, unless you got one right now, you can just email me with like, Doug, I think this, we got to do this instead of that.
Doug, can we zoom out for a second?
Huh?
Can we zoom out for a second?
Well, I don't know where we are. Where are
no, I mean,
discussion-wise.
Discussion-wise.
Oh yeah.
So, so you have this line following simulator. Is your plan to run this live in a video session or a Zoom meeting or something like that? Or
yes.
Yes. I don't know if it's built to be friendly for this, but think about the possibility of running multiple robots in a heat at the same time and not having to worry about collision avoidance. You can sort of let them pass right through each other, but it would add some visual interest and make it a little bit more competition-like seeming, I guess.
Okay, I think, Kareem, I had not gone to that idea, but I had thought, we could have four windows open at the same time with 4 different robots running at the same time. They wouldn't be on the same course, but they would be running at the same time. And you have,
yes, you could do that.
And you could put them all in the tab mode, the overview mode with the breadcrumbs. Do you guys remember that?
Yeah.
Okay, so they could all be running, so you could actually see the progress of the 4 robots running together. Now I'm assuming that I could do that on my machine. I haven't tried it yet, but I mean, it just should be 4 instances of processing. So I don't think it would be a problem.
It may share some global variables. I don't know, but it sounds like a good idea. But more fun to watch.
I think I can have unique. I think I can have unique processing instances.
It sounds like a nice to have.
Yeah.
My big concern is that it's September 1, and if we're going to do this, we're talking about November 2nd Saturday.
Mm-hmm.
So that's a lot of time to communicate. I think it's not much time to communicate to people and to have them warm up to this and do things.
You might want to think more December. I agree. But, it may take time.
Hey, Carl, since this is truly virtual, we could do it on a Tuesday. We could do it, and there's no reason we have to do it on the 2nd week in November. What I'd rather on the 2nd week in November is do the real live contests. If we decide on a subset of real live contests, I'd do that on the 2nd November. Okay, like it would be cool. But anyway, we got to figure it out. Maybe we might not be ready. people probably have not been building robots.
Okay, that's what I'm trying to get at is that in a way we're late to the curve to the normal planning schedule.
Yeah.
So I would suggest that maybe what we need to do is send a mail out to the D list and say, with these ideas, like we've done before, put your hand up if you're interested to compete in one of these. Outdoor by second Saturday in November, virtual by second Saturday or whatever of December.
Yeah, I would think maybe instead of I would even push the outdoor to the third week of November and use the second Saturday for any indoor scheduled contest that we decided to do. You know, like if we're going to have, like, say, 6CAN, one of our traditional second, or if you wanted to do, we could have the courses all set up. And so you come in with your robot, and let's say you wanted to do, I can't remember the name, 4 squares, or you wanted to do there and back, or whatever it is, and you wanted to do 6CAN, you would run the different courses. The judges would note your times and stuff and take video. And then you would go home. It's not as good as everybody being there. I don't know if we can get the lift in spirits, But
Well, that's my point. So to concentrate our effort, I'd say, let's see who would participate if we did this, and then based on that, then we can decide and commit, and then that's what we'll do.
Yeah. The nice thing about the simulator line following contest is that it's got a pretty low bar, and anybody, like I say, the example can do the advanced course. You just can't do it very fast. You need to figure out how you would do it if you really wanted to do it fast.
Yeah.
And it can be done anywhere in the world. Murray could participate in it. The people in California could participate in it. Anybody, right. People up in Seattle anybody could participate in it. And if the more people that participated in it, the ideal thing would be is, we could learn something from it.
That's why I think it'd be nice for us to focus energy on the one thing and do it well. That's my point.
Okay, well, anyway, that was kind of my initial thought too, and so that's the reason why I spent the time. Now, but these other ideas are good ideas, and we probably, like you said, ought to send it out. I think Carl ought to send it out personally.
I'll send it out. Those 4: freestyle, open style, Robo Columbus, course-based 6CAN.
Well, you could list the courses and say, hey, who would want to run what. And I'm just saying that it's when a guy came and visited if it was in the Dallas makerspace, he would come in and he would run all of the courses he had said he would run, or that we had set up. Yeah. Traditionally, we do 3.
So, quick question, guys, to do with the physical robot contests that you're talking about. If you do elect to do those, would you also allow for virtual entries? In other words, the video shot.
That's a very good question, and I'm not. If we do it the real thing comes up is, Donna, is okay. Let's say we do a 6CAN contest. I know you're not familiar with that, but it's a 10 by 17 foot course, has 6 soda cans. It basically looks like a walled soccer court, and you got to go get the 6 cans and bring them back. All right. So, I would be okay with videoing that, and it doesn't actually need the wall. You can tape the boundaries. Do you follow what I'm saying? The walls actually provide some opportunities for people to do things with sensors that they might, otherwise you can always square up on a wall, where if you didn't have a wall, you wouldn't be able to square up on it. There's a few other things that can be done, but the chances of somebody making a 6CAN course is probably very slim.
In the next 2 or 3 months.
Yeah, it's just it's
and even if they did, right, the chances of it behaving the same are not good. So there'd be some normalization, right? But I think it'd be interesting if we could, if we between the two groups picked one or two of the same contests, if we had interest. And
yeah, and I'm sure that goes both ways. That's another good point.
Absolutely. Absolutely.
Society of Robots has contests. Maybe we create a arena here in Dallas and run the contest here in Dallas, and you run the contest there, and then we ship video results or something like.
Right. Yeah, I agree with that, Doug and Carl. Mostly what I was thinking about for the virtual only type concept was the open
freestyle.
The open or freestyle type is what I was thinking.
Yeah,
in other words, most creativity involved in whatever that builder wants to show. That's more what I was thinking about.
If I were making the rules for that, here's how I would probably go. After defining the categories they could enter in, then I would say they have to submit a three-minute video showing the robot doing what, if they claim that they can say make the perfect martini, then we would want to see them making a martini. Do you know what I mean? I don't know if you ever seen that YouTube video where the guy puts this thing on his hat and it feeds them, and it kind of even that would be a good video because we believe it,
So then it sounds like really the only modification we'd need probably then is to, if we're going to have common judging, and where there's a winner in Seattle, and then the first two are in Seattle, and then the one happens to be in Dallas, for example, then we would want to have judges. We'd want to have good representation from both clubs, right? In a way where they could reach a consensus.
Yeah, well, I think you'd have two panel of judges
in a fair way.
They would vote them up, and then usually those things, what you find is the top two are going to fall right out on both sides. You know what I'm saying? Usually there's going to be consensus, and then it's when you get down to number three that it gets like, well, I like this guy and you like that guy, and I don't know, So, but we could work that out.
Right.
Now, that's one thing I do think is very important. And I think we need to do this, Carl. DPRG makes little plastic trophies and sends them out. Gives them out. Haven't done that in the last year or so. Yeah. But for this, I think we need to start that back, and that way, like for example, if Murray won, you know what we're talking about, guys. Maybe Donna.
Yeah. So it's the prizes, right? Because when we have remote, then the prizes get to be interesting too. So.
Yeah, here's an example of one. These are laser cut, and they're made, and you get to put it up. It's not a big deal, but it's fun to have one of these. So anyway, that's an idea.
We'll work towards that. I'll send a mail out to the DPRG list, and Donna, when I get your email, I'll copy you on it.
Okay.
Okay, great. Thanks. By the way, I plan on joining your email list soon. So.
Yeah, cool. Yeah, and I put my email in the Slack there, so you can get me directly.
Yeah, it's not like you're going to be covered up with emails, Donna.
I have to say I've got to go, everyone. So I'll see you next
week.
time.
We'll see you, Murray. Take care. Thanks.
Yeah.
Yeah, it is getting a little bit late, so I'll take an action. I'll send it out for club interest, and.
Carl, do I have audio?
Oh, sorry.
Do I have audio? This is David. I seem to have lost my camera.
David, we hear you. We hear you, but we don't see you.
Can I weigh in here? Or
Please.
are we just getting shut down?
I was going to say, let's shut down and do it a little earlier because some people have to work tomorrow. Okay? So
David,
it's after 10:30, Doug. I don't know if you all know what time it is, but it's 10:38. So.
What? Do you have a quick comment, David?
Oh, I don't think I've ever had a quick comment in my life.
Okay. Well, let's revisit this next Tuesday then, because I don't think anyone should feel compelled to stay on, but in the interests of those of us who do have a job, let's get to bed.
So, or else let's add a little to the earlier time, like at 7 instead of 7:30. I mean, you know, if you want to do that, let's do that type thing.
Seven regular time, 7:30 next Tuesday, and both jealousy and no remorse to those of you who are retired. So. Okay, guys. Well, have a good week, and we'll catch you next week then. Thanks.
Yeah, thanks, everyone.
Bye, guys.
Thanks.